Hello friends, this is Rupesh and you're watching CPPNet's video series on C++. And in this video, we'll be learning about void and void pointer. Okay, so lots of people get confused like where to use void and what is the use of void pointer and what actually it can contain and all that. Okay, so I have tried to catch all those points and this is the summary for that. Okay, so let's start with the void now. So void means nothing. First point is void means nothing. You will use this to denote nothing. And what is that nothing? If some function is not returning anything, then we use void type to denote that. And let's see what is that. So if some function is like this and you are doing whatever you want and just simply returning from here or just returning nothing. Okay, this nothing means you're returning void. And let's suppose you're not writing this, then also this is okay. Okay, so this is one use of void data type to denote that some function is not returning anything. Let's look at the third point. If some function does not take any parameter, then we use void to denote that. And the same thing for parameter as well. So if you're not taking any parameter, you will denote that with void. Okay, so if someone is seeing your function's declaration like this, they will be knowing that okay, you're not returning anything and you're not getting anything inside this function. Okay, so that is the second use of that. Now let's look at the fourth point. We cannot create a void variable. That is something which is important. You can use void in functions return and parameter type, but you cannot use it like this, x is equal to 10 or something, or even just simple void x. No, if you will compile this, it will throw an error saying that variable or field x declared void. It means it is universally known that you cannot create a variable of void. Okay, so that's another point. And yeah, fifth point is little interesting point. It says that if you are taking the size of void like this, size of void, then if this compiler what I'm using is GCC, then it is 1. Okay, GCC standard says that the size of void is 1. So if you will print that, you will get 1. See, in tiny this corner it is printing 1. But still we are giving the warning here like you are getting the size of a void type. Okay, but if this is, let's suppose, a visual compiler, I mean Visual C++, a Microsoft compiler, then it won't. So let's check that. So in order to check that, I have one website here. This I will choose as a C++ VC++, okay, Visual C++, and wait for some time, it will set. Yeah, now we are set. If you will try to do the same thing here like std cout size of void and just std endl, if you will run this, you will get the error. See, it is an error. Void illegal size operand. So you cannot pass void inside size of. That's the rule in Visual C++ and C. But in case of GCC, it is 1. Okay, that's something you can remember if you want to. So that was about void. If I miss out something, please give me in the comment. It will be really very helpful for others and I would really appreciate that. So let's go for void pointer. I don't have much about void pointer, but let's talk about the first point. Void pointer is a universal pointer. And why? Let's see here. In second point, we can convert any data type pointer to void pointer except function pointer, constant or volatile. Okay, so if your pointer is a function pointer, you cannot typecast into void pointer. If your pointer contains constant, then also you cannot go for void pointer, and same for volatile pointer. Okay, except these three things, you can typecast almost anything into void pointer, and that is up to my knowledge. If you know something else, you can comment. Okay, I would always appreciate that because it would help others as well. So to demonstrate this second point, let's write some code here. So the second point is your void pointer can hold any pointer. So let's create some dummy pointer here. integer a is equal to new integer, let's suppose you are having this value 10, and void pointer v is equal to a. Okay, if you will compile this, it's gonna get compiled. Say it has compiled, so there is no problem in this. You can assign integer pointer into void pointer, and as I told you in my previous video, we talked about static cast, and here comes the use of that void pointer. So if you'll compile this, it will work, and we should typecast this using static cast. Okay, because this is a compile time check, and we should always go with this kind of cast first. Okay, if we are typecasting something like this. And as I said, you cannot typecast function pointer, so let's see that as well. So if I'm having something like void function, and this is a function, you can see that. Let me give a space, and what you're doing is just simply typecasting this function fun inside void pointer, but it won't do that. See, it's an error, invalid static cast from void. This void double bracket means it's a function, and you're just typecasting that into void pointer, and that's not allowed. Okay, so it shows that you cannot use function pointer in case of void pointer assignment. And as I said, constant also has the boundary, so let's check that as well. Integer pointer I is equal to new integer 10. So if you will do this, let's compile. See, still it is telling that invalid static cast from constant integer pointer to type void pointer. And if you will just simply remove this constant, let's compile this again. See, it's successfully compiled. It means you cannot convert constant pointer to a void pointer. Okay, and this one is a volatile, and same goes with this one. So let's try volatile, and if I'll compile this, see, it is telling you the same thing. Okay, so we have seen all these points. Now look at the third point, which says that you cannot dereference void pointer. And what do I mean by that is like this. If you want to print something, you cannot use something like this. Okay, because to dereference something like this, you must be having a type. Okay, some non-generic type, I can say, because a void is a generic type. It's like you can assign almost anything except this, okay, to void. And we'll see where we can use that. I have listed some use cases here. That is some another point, but third point is you cannot dereference that. And let's compile that. See, we got the error. Okay, but you can always use it by typecasting back to its original type, which is this one, like static cast integer pointer and v. So if you will typecast it like this, and you have got this 10 now. Okay, so you can use it like this. You have to go back and then dereference it. Okay, so that was about void and void pointer. Bottom line says that, first bottom line says, which is the only bottom line I can say here, is void means nothing and void pointer means pointer to anything except function pointer, constant or volatile. We saw that. Okay, now come to the use cases where generally we use these things. The best use, which maybe each and every programmer would understand, is malloc and calloc. We would have used it like this. Let me give you the demonstration. If it is like this, malloc size of integer, so that's how we use it. Will create 4 bytes of memory, and malloc always return void pointer, and that's the key. You always typecast that void pointer into integer pointer. Don't forget that we write like this to typecast the void pointer, what we get from malloc, into integer pointer and assign that into the variable. Okay, some people might say that we don't write this, but still it works, and that's because there is this implicit conversion in C. But if you'll write this kind of code in C++, it won't work. Okay, so let's compile this code like this. See, it has compiled here. Now if you will remove this and compile, it will say error. Okay, so this is not valid code because there is no implicit conversion in C++ for malloc and all that. You have to be explicit about that. Okay, so either you are using this one, this is a C style casting, or you have to go with static cast. Okay, which would look like this: static cast integer pointer, integer pointer, and we're done. See, compiled. So this is not the point. The point is your malloc function return void pointer. That's why you can typecast that void pointer into any pointer. Like here we are using integer pointer. Someday you might use a character pointer. Okay, character pointer C is equal to malloc and all that. Or sometimes you might use double pointer D is equal to malloc. Okay, like that. But this malloc will always return void, and you will just typecast that into your respective pointer. So that's the use of void pointer. Generally people don't know. If someone asks, they will be just confused. So this is the best use, you can say that. Okay, and second use I can say is void pointers are used to create generic functions in C. If you remember, there was a compare function used in qsort function in C. So this qsort is an inbuilt function provided in C which takes a compare function, and compare function takes two parameter as void pointer, and there was generic pointer. So I think I'm done here. If I left something which you know, please comment. It will be really helpful for others. Thanks for watching. I'll see you in the next video. Bye bye. Hello friends, this is Rupesh. You're watching CPPNet's video series on C++, and in this video we'll be looking into this encapsulation topic in C++. This is a very easy topic and you will get it just like a snap of the finger. So let's start this. Encapsulation is an object-oriented programming concept which talks about binding together the data and the function that manipulates those data. Yes, binding together data and the functions happens in class. Yeah, so let's create the class here. As usual, we will have this base class. Here goes your data, okay? And then public, and you will have some functions here which you will call to manipulate this particular data. Or if you are having 10 or 20 data, you will be calling those functions. So let's make some functions here. So set x, which will set the value of x integer, get x, which will return the x. So return x, and x is equal to a, and here we are getting a. Okay, so this is the function and this is the data. You encapsulated these two things in one thing, and that is called base. So can you see here, you are encapsulating two things, the data part and the functions which will manipulate that data. Okay, so your class is a perfect example of encapsulation. Okay, generally what happens in encapsulation, like if you are looking at some capsule that look like this, right? So let's suppose you have some capsule, it looks like this, then it has two parts. One is a data part and another one is the function part. So data is this one, function is this one. You encapsulated these two and called it base. That's it. So let's read this. Class is an example of encapsulation because it does what we need. And if we have created some class and have data member and the member function in that, it's an example of encapsulation. Yeah, because sometimes what happens, you create the class but you don't have the functions for that. Everything you keep as public and you just accessing it from main or some outside function, then in that case, that's not the example of encapsulation. The encapsulation is your data and the functions should go together, okay? Because you have the option of not including this function, just erase this and make this x public. So instead of this one here, you can make this x public. Now, if you are creating any object here, you can access that, right? So I'll just show you that. So instead of these functions, you know these functions will do their job, right? But you can have something like this also, like public. And now, if you are making some base b and b dot x, you can set here and you can get it, okay, like this. So if you'll compile this, this is a perfect code. See, you got 10 here. But the problem with this case is you are missing this function part. You don't have these functions, you just have the data, correct? So that is not the case of encapsulation. This is something else. I don't know what to call this one, but surely not the encapsulation. So this was about encapsulation, and if you want to know what is abstraction and data hiding and all that stuff, watch my coming videos. You'll understand that so nicely. So thanks for watching, and if you like the video, don't forget to hit the like button, dude. And if you haven't subscribed my channel, go for it, because I'll be uploading videos like this and you will get the notification right away. Bye bye.
Hello friends, this is Rupesh and watching C video series on C++, and in this video we will be looking into this constant member functions in C++. So yeah, you have constant member functions, and the use of that is it restricts the modification of data members inside function. But you still have one way of changing that, and we'll see how it works. So let's create that traditional class base, and let's make this integer x and default, and the parameterize integer a. You might think I'm keeping this all the time similar, right? But there is a reason for that. If I won't do this, you will find hard to remember stuff. Now you can relate, okay, from the previous video. That's why I'm keeping all these things similar. So now the question is, it restricts the modification of data members inside functions. So let's create the functions, and let's create some getters and setters. So void set x, which will set x as a, and we'll get a here. And let's make integer get x. This is gonna return x. Okay, now what you want to do is, in this function, what you are just doing is you're just taking this x and returning from this function. You're not changing this x. So what you can do is you can create this function a constant function, and it will say that I'm a constant function, I will not be able to change data members. So if it is non-constant member function, whatever data members it can change, after making this function constant, it cannot change those data members. So this is the way of making it constant. After writing this, the function name and these round brackets, this becomes a constant function. So let's just quickly see this. If you are having this b here and b dot set x, you are setting this value as 10, and b dot get x, you should be getting that value, right? So let's print this. See, we got 10 here. It's cool. Now I wanted to tell you that if you will change something, let's suppose you're saying get x, but you want to change it into 20 inside this, and after that you want to return that x. So if you will compile this, you will get the error. Assignment of member, this is read-only object. So this is what I said, but there is a way actually. So that way is this mutable keyword. So if you will make this data member as a mutable, it says that all data members are not allowed to be changed in constant, but this mutable is. So now it will compile. Let's compile this. See, it compiled and you got 20 now, because you call this function and it changed the value, and then you are getting this x. So you got the changed one. So if it is mutable, then only it is allowed to change inside this constant. I will show you it another one. Let's make it something like y here. Not required to initialize it here, but still okay. Y and b, and just do this. Y is equal to, make it 30. Okay, so there is no problem with this, but there is a problem with this. So let's compile and check this. See, it is telling here assignment of member and the same error. Okay, so that's it. This is the use of this constant member function. This is a great message to the viewer of your code that this function is only for the purpose of returning something, but surely it will not change any data members. And if that guy want to verify that, that guy can just simply see this data members. Are they mutable? If they are mutable, then they can be changed here. If they are not, then this function is totally constant function. Okay, so that's it. If you like the video, don't forget to hit the like button and make sure you subscribe to my channel so that if I am pushing any video, you will get the notification right away. Thanks for watching. I'll see you in the next video. Bye bye.
Hello friends, this is Rupesh and watching CPP video series on C++, and in this video we will be looking into this data hiding concept in C++. So let's read out this first comment here. Data hiding is about data member in classes. We keep data members as private, and this is considered as data hiding. Nothing else. Only this much. If you are keeping something inside your class as private or protected, and you don't want to share that, or you don't want that thing directly to be accessed from outside world, that's where you are hiding the data, and that is called data hiding. Okay, when I started learning C++ and when I came to this point like data hiding and all, I was like, maybe it is hiding the important information so that no one can hack it. So this came in my mind because that time hacking was so popular and everyone was hacking here and there because systems was not that great. So you will always listen that, okay, somebody hacked this one and somebody hacked that one. So that time it was like this. So I came to this conclusion, right? Okay, maybe it's because to prevent the hacking, but it's not about hacking. Okay, it is about correctness of the data and preventing the accidental manipulation of the data. So what you are saying is, I will be keeping something as private. So let's create some class here. No, first let's read this one. Audio player volume increase. So this is the example I have chosen for this particular problem. So what happens, you have some player, let's say ABC player, whatever it is, and you want to set the volume, and you have been given from 0 to 100, and this is the bar. You can set this much, right? Generally, this is the values you can go for in volumes. So let's create a class. We'll get it better. So ABC player. I don't know whether this kind of player really exists or not. And we can have just one button called volume, and let's keep it private. And there is another thing, that is a function set volume. Okay, and here you will send the volume. Let's say you are sending the volume, and this is the function which is going to set that volume. So the possibility is, see, you will be having this as a public, correct? This function is public so that you can set from outside. So from here you will set it. So let's make this ABC player ABC dot set volume. Okay, and initially maybe when your player will start, it will be initialized with 0. So let's create a ABC player and initialize it 0. So if you are creating some object, the volume will be 0. So initially it will start from the 0, and now you want to set maybe 50. That's it. And let's do one thing, just copy and paste this volume is equal to X. That's it. Then what if I'm sending ABC dot set volume minus 30? Is this going to work? Yes, it is going to work. So what you will do, you will write a very smart program here now. You will set volume is equal to X when this condition will pass. If X is greater than equal to 0 and X is less than equal to 100, then only you will do this. So here comes the data hiding part. You have hidden this data and given the interface to change that data, and that interface you have implemented in such a way that your data should be in always good state. Your volume should be always from 0 to 100, right? So if you are passing minus 30, then it should not set that volume minus 30, and in this case now it won't. So we can have just simple message here. If you have set it, then set, and if you could not set that, just print can't
set. So if you will run this program, let's hope it will compile. See, it has given set and can't set. So 50 is a valid value for this volume, but this minus 30 is not. And not only minus 30, if you are going other than this value, maybe 1000, so you cannot set 1000 value, and you can set 0 value. Let's remove this. So if you're setting 0, it's okay. So let's compile this again and see the same value. If you will make this one something else, now it won't set value for either. See, can't set. So actually this is not the point. The point is you're hiding some data. This is the data, and giving the interface for that data to be changed, and you're carefully implementing that interface so that you accidentally don't mess up your data, which is this one. Okay, and suppose you are not giving this interface, let's just simply comment this, and what you can do is just copy and paste it here. So actually you're making this non-hiding stuff. Okay, so you're not hiding this volume now, and let's remove this. So what you will be able to do is abc dot volume is equal to maybe 30,000, and this will work. Okay, because this is public and you're setting it. So you can see the potential risk in these kind of implementation. That's why generally we keep the data inside private section, and we give the interface like this to set and get those data. Okay, so don't forget, it is about correctness of the data and preventing accidental manipulation. Okay, this is just about that, nothing else. So thanks for watching, and if you like the video, don't forget to hit the like button and make sure you subscribe to my channel so that whenever I'll push some video, you will get the notification at the same time. So I'll see you in the next video. Bye bye.
Hello guys, this is Rupesh and watching C++ video series, and this question is about function hiding in C++. And this is pretty uncommon question, and if it is uncommon, you should be knowing that, right? So let's try to understand what is function hiding. So this is your base class. You have this function in base class, and this is derived class, deriving base class, and the same function name, but the parameter is different. Okay, don't think about this integer return type. I could have written void, doesn't matter. And here you are having derived object d and calling function with 1, which is integer, so it is this function, and function with character, which is this function. So what you expect? First it should print base and then it should print derived, right? Because this function has come here because we have derived it, correct? So let's run this and check it. Okay, we have derived and derived 2 times. It means both the time it is calling this function only. So this is called function hiding. I'm telling you, when you have the same function name inside your derived class, then all the similar name from base class will be hidden inside your derived class. Okay, so it doesn't matter your parameter is different, you have 2-3 parameters, doesn't matter. You cannot use that function inside derived, I mean using this derived object. You can do one thing, you can just simply call like this, base function, I mean by using the scope resolution operator. So if you will do this, see, the answer is base and derived. So there is another way of doing that actually. You can use something called using, which will be used like this. That's it. So now what you're doing, you're telling that I want base class function scope should come here. Okay, so what you're saying, all the functions which have this fun name inside this should share the similar scope what derived is sharing. Okay, so ultimately this function scope will become local here. Okay, so now you can use this, just run this, see, it is base and derived, and you are not using that scope resolution operator here. Okay, but still it is working.
Why it is working? I told you. Using this, you are telling that from base, whatever is there with this function, there could be so many functions from base here. Let's call some another function here, and this is, let's call this a void function. Void. Okay, and if you are calling this here without any parameter, let's run this, you will see that this void is coming. Okay, so what you are saying is, I want all the functions with fun name inside here, or you can say you are making those functions scope local to this derived class. Okay, and as I told you, if you are not using this one, then you need to use scope resolution operator, then it will work. Okay, so let's run this. See, derived and derived. So for these two, it is calling this only, but as you are using the scope resolution operator here, it is calling the void one here. Correct? So to bring these functions scope local to this derived, we use that syntax. And another thing is, if you are creating some function, let's suppose you are having this one. Okay, so you might think, okay, because of this one parameter only it was getting confused, so let's pass two parameter, it will call that function. Okay, but no, it won't call that function, and this is a compile time error. Okay, why? Because this function is not here if you are not using this one. Okay, so let me clear that. And if you are calling this function 1 and 1, it means it should call this function, but it won't call that. Okay, so let's check that. See, you got the error here. So what we learned from this video, that if you are using any function name in derived class, it will hide all the functions coming from the base class with the similar name. So this is called function hiding, and to overcome this, we use this one, using base and that function name. Okay, so you learn a new thing, right? Function hiding. I think we're done here. Thanks for watching, and yeah, don't forget to subscribe for videos like this. Bye bye. Hello friend, this is Rupesh. You're watching CPU video series on C++, and in this video we'll look into this friend function and friend classes in C++. So there is a keyword called friend, and that is used to make some function or class as friend of your class. Okay, so we'll go through all these points. So first, let's quickly create a class. So let's assume we have some class base here. So first let's take the example of a function. Later we'll go for class. So let's create some function. Let's make it void set, and then you will have this base reference object integer x. Okay, and inside this function what you're going to do is object.x is equal to x. Okay, so ultimately you are accessing this .x, which is a private data member outside the class. So this is what friend function allows. Okay, I mean, if you have made some function as friend inside your class, then that particular function is allowed to access your private data. Okay, because you said that that particular function is my friend, so compiler will allow to access your private data inside this function. Before, if you have watched my previous videos, I was giving set functions like this, void set here inside this, and here we was getting integer a, and we were doing something like this. Correct? So this is obvious case, like if this function belong to your class, then obviously then this function can change or access x. But what if some function doesn't belong to your class and still you want that function to be able to access your private stuff? Then you will use friend function, and this is how you tell that some function is my friend. So you got this function and this is your class. Now you have to tell that this function is my friend. So this is the way of saying that. First you have to write friend, then this syntax. Okay, so base ref obj is optional. If you want to write, then write, otherwise it's okay. You just need to define the types only all the time here. Okay, this is the function. You said this function is my friend. Let's create some object and let's assign some value inside that. Let's make it 10. Call this function and pass this object here and pass some another value. Let's make it 20. So what will happen when initially your object was created, this 10 will go here and this x will get initialized with 10. So object having this x and that is having 10 value. Now what you are doing is you're changing this obj and want to assign 20 inside that and using this function. This is not a great example, but it will show you the use of this friend function. Okay, so you're calling this set function, which is this function, and inside this function you can access this dot x because this is a friend. So let's compile this. It should compile. Oh, what happened? Oh yeah, actually you have created some function, your friend, but that function signature is not matching. How can I miss that? Integer. Now you compile. See, it has compiled successfully. Let's create another function which will get this value for you. So get, and that will return that obj return obj.x. This is what you want. So let's make them in one line, so it will take little less space. And yes, you are right. If you are accessing this x here, then you have to make this function also a friend function. So friend, okay, this time I'm not missing, right? Okay, now let's do this. Cout get obj and compile. See, you got 20 now. Okay, so you set 10. Let's call this cout after 10 also. So if you will run this, you will get 10 and 20 both. Okay, so that is correct. And if you are confused why this .x cannot be accessed outside this class, I'll just show you the example here. Let's try to access that. Okay, you're thinking maybe you can access that obj.x, but you cannot access that. If you'll compile this, you'll get the error saying that base x is private within this context. It is saying that this is a private thing, you cannot access this outside this class. So sorry. And not only this, I mean this private, it can access protected also, and public is already accessible, so there is no question about this public, but it can access protected also. So if this is protected, then also there is no problem. So protected and compile this. It's this one which is making problem for you. See, it was telling that this is protected and you cannot access that outside. Okay, so if you have removed this, compile it. See, compiled. So this is how you make some function as your friend. And notice one thing, this relation is like this. There is one class and that class makes some function. This is your function and this is your class. So this function will be declared as friend inside class and you are supposed to declare that. Okay, no one can come and tell that okay, I am your friend. No, you always says that that is my friend and this is my friend. So there is this class, you are the owner of this class, you will say that this particular guy is my friend. So this is how you will do that. Okay, now another thing, there is another class. Yes, one class also can become a friend class. Okay, so instead of making some function, now you want to make some class as your friend. But notice one thing, this particular thing is always class. Okay, this class is telling that this guy is my friend, this class is my friend, but this is not function. Okay, it cannot be like this. One function is there and this function is telling that this class is my friend or this function is my friend. No, this is not there. Okay, so always class is there and class tells this function is my friend and this class is my friend. Okay, so till now we saw how to create a function as your friend. Now let's look at the class example. So let me just simply remove all these things and let's quickly get rid of this and maybe this, and let's create some class here. Class get set. This will have these functionalities, so it will get some values for you. Okay, so the same functions what we saw here, getters and setters, will implement inside this class and we'll just simply make this class as your friend. So friend class get and set. So this is how it will look like, and if it is set, it will have base ref obj.integerx and it is going to return obj.x, and here we'll set obj.x is equal to x. So this functionality is pretty much the same what we saw in the function case, but this time you are making this whole class as your friend. So every member function can access these private and protected. So let's make this private for now. Now here is one thing. In C++, the compilation goes like this. Your compiler will come here and it will check, okay, everything is fine. It will come here, it will come here, and it will check what base. I have not encountered base yet. I don't know what base is. So it will show you the error here. Let's check that. See, error, base has not been declared yet. Okay, so if you will keep this base from here to here, and if you will compile this now, it will work. You are just simply saying that this is going to be your friend, and if this friend doesn't exist at all, let's just remove all these things and just compile. Then also doesn't matter, because tomorrow morning you can just wake up and say that, hey, John is my friend. Who cares John exists or not? But in this case, I mean in this get and set case, the error was because you are saying that my object will look like base. Okay, because this was like this right here, and you're saying that my object will look like base. So compiler don't know where is the base, but in this case you're saying that someone is my friend. Compiler don't bother. If that friend is accessing your private stuff, then compiler will check, okay, it is allowed to access, I mean it is allowed for that particular class or function to access your private data parts or not. So I think that's clear now. So let me keep it here. So I think it makes sense. So before you saw friend function, now you're going to see friend class. So this whole class has become friend of this class. So let's do some experiments here. So as you have this get and set, let's create the object of that. Get and set. So cout gs.get, and you will send the object, and after that you will set the same object with different value, and let's call the gs.get object. This is, yeah, here endl is required, and I don't think we are missing something. Yeah, we are missing this one. Okay, so what we are doing here is you have this object which is initially 10. I mean this is a 10 value. I mean this x is holding this 10 here. Now you created this class. Class has this function, so it's pretty cool. You're calling this function and passing this object here, which is coming here, not here, here, and just returning .x. Okay, and this whole drama is happening just because you cannot access this .x, which is private. So this whole thing is happening just because you want to access this private, so you want to become, I mean, so someone have made you as your friend. Otherwise there is no need of doing all these stuff. Okay, so let's compile this. and see 10 and 20. 10 and 10. It's pretty cool, huh? So instead of writing so many functions as your friend, you can put everything inside one class and make that particular class as your friend. So all the functions inside that will automatically become the function, friend function of your class. Okay? But wait a minute, that is not the ideal situation. Okay? So you should not make things like this. Until unless it is really required, you should not go for friend functions. You should include some function inside your class if you think that function should get your private data members. Okay? And if you want to see where you can use friend function and classes, then watch my another video. I will be giving the link in the description field. There I have talked about where you can actually use friend classes and friend functions. So you saw that you had friend function, before this example, and this is your friend class. And this is the only use of friend keyword. And this whole thing is happening just because classes have this kind of protected and private data, and you explicitly want to give the rights to non-member functions that they can access your private data. So let's read out this whole thing again. Function cannot become friend of another function. Yeah, that's what I told here, right? One function cannot become the friend of another function. There's no sense in that. Class cannot become friend of function. As I said here, if you have some class, that class cannot become friend of some function because this is a function. Okay? A friendship is not mutual. If a class A is friend of B, then B doesn't become friend of A automatically. Yes, that is very important point. This base is saying that getSet is my friend, so getSet is allowed to access .x, which is private inside base. But as base has said that getSet is my friend, it doesn't mean that getSet is saying base is my friend. So if getSet is having some private data inside that, this base cannot access that. Base can only access when this getSet will say that, yeah, base is my friend. So if you are declaring this base as friend here inside this, then only this base can access. Okay? So that is a good point here. Now, friendship is not inherited. That is also a very important point. So if you are a beginner, you may find it a little difficult because maybe you don't know inheritance. But let's assume you know an inheritance. So if this is base and there is this getSet function, class, and here you are using inheritance, make it public base, and let's make some function as friend, not class. So function. Okay, so this is some function, simple function, and you say that this simple function is your friend. Okay, so this is what I'm talking. There is a class. This class is telling that some function, this one, is my friend, and that class is inherited inside another class. Then this class will not have this function as friend. Okay, remember this. This class will not have this function as friend. So friendship is not inherited. This is also very important point. Someone can ask you in the interview questions. Okay, so this function will not become friend inside this class. So I think we are done here. I hope you liked the video. If you liked it, don't forget to hit the like button and make sure you subscribe to my channel so that whenever I create some videos, you will get the notification at the same time. Bye-bye.
And in this video, we'll be learning about static cast. So in previous video, we saw that how to use const cast and where to use and where we should not use that. And in this video, we'll be learning about static cast, and I have almost 5 to 6 points here to discuss. So let's start it. So this is the first demonstration program. Here I need to uncomment that, and it tells that it performs implicit conversion between types. So implicit conversion is like what generally C++ or C compiler does when you are typecasting integer to integer to float and float to integer and integer to character and character to integer. Okay, so those things comes under implicit conversions, and we should always use static cast in order to do that. Okay, so I have given this
normal implicit cast and this is our static cast. Both are doing the same thing. But let's suppose your program is failing somewhere and you want to check where am I doing all those implicit cast. So searching this line in whole bunch of code is really very hard. So that's why we should use static cast in that case. So you can just search it. Okay? Otherwise both will be doing the same thing. But this is explicit message that I'm using static cast, and static means this type casting will happen at compile time. It won't go at runtime. Okay? So it will check whether I can typecast f, which is of float point, into a, which is of integer point. Okay? And I have given this comment, you read it out. Okay? So this was the first point, we should use static cast. Okay? Let's go for the second point. And second point tells that use static when conversion between type is provided through either conversion operator or conversion constructor. So we will see that here. If you don't know what is conversion operator and conversion constructor, we'll learn here. Okay? So we are having this integer class. This class is taking integer as a value. This class has an integer x as a data member, and we have this object here. These two lines are very important. Okay? Here we are using a conversion operator. See, you are initializing object of type integer inside string. How is it possible? Both are not equal, right? But still, if you will compile this code, it will compile without any problem. Okay? Let's check that. See, it has compiled without any problem. And why this is happening? Because we have this conversion operator here. Okay? We are initializing into a string. That's why we are having conversion operator for string. If you want to initialize your class object to something else than string, you have to provide the conversion operator for that as well. Okay? So object is being initialized to string data type. Okay? So this function is being called. We are typecasting x into string and passing, and that x is getting initialized into this one. And this is also a weird thing. This is talking about the concept called conversion constructor. The rule of conversion constructor tells that if your class has any constructor with one parameter and you are initializing the same data type parameter into the object, we will call that constructor. Okay? So let's print the message here, like what is getting called at what time. So this is conversion constructor, and next one is here, this is conversion operator. Okay, so we will compile this and we'll check what is being called at what time. See, conversion operator, conversion constructor. So the first thing is conversion operator. Okay, so this was called, I told you, sorry, this one. Okay, but why we are discussing everything here? The reason is we know what will be called at what time here, but here if somebody is looking at your code, they won't be able to understand it much because they don't know what type of casting is happening. And this is a compile time casting, so you should always use static cast for that. Okay, so this first expression should look like this one, and this second expression should look like this one. Okay, ultimately this assignment is also doing the same thing what we are writing here, but we should explicitly write that. Okay, so the reviewer or somebody else is looking at your code after 10 years, they will be able to know, or even in debugging phase it is really very important if you want to find where all those static casts are happening. Okay, so here also we should use static cast, both the cases, conversion operator and conversion constructor. Okay, so this was our second point. Let's move to the third point. Third point tells static cast is more restrictive than C style cast. And let's see why I am telling like that. Because character pointer to integer pointer is allowed in C, but not with static cast. And this is really a very dangerous cast. If you are casting character pointer into integer pointer, it means that you have a character pointer which is pointing to 1 byte memory location, and you are typecasting that 1 byte memory location to 4 byte memory location, Now if you will use this to write into memory, it will write 4 bytes. So that's the example here. See, we have a character C, typecasted that address into integer pointer, and you are updating that integer pointer, which is a 4 byte, with 5. So what it will do, we'll see with this diagram here. You have memory like this, and you have somewhere this address of C, which is 1 byte. Okay, now what you are doing, you're typecasting that address into integer pointer. So what this will do, it is like now you are pointing to the same memory location, but now you are having 4 bytes into your consideration. So if you will use this pointer, which is this P pointer, and initialize 5, what compiler will do, compiler will initialize 5 on all these 4 bytes. So it's like it will initialize 0000101 like this. And what you're doing here is you was allowed for this particular block, but with the help of typecasting, which is this one, you got access to the nearest bytes also, which was not allowed for you. So in this case, you might corrupt your memory, you can go to segmentation fault, lots of things are possible. But that's not the point here. The point is here C style casting. This one allows this. You should be getting error for this, right? But no, your C style casting is allowing this. But if you will use C++ style casting, this is not going to allow that. Okay, these two things are exactly equal. I mean, you're typecasting character pointer here to integer pointer, and the same thing is happening here. You're typecasting character pointer into integer pointer. Okay, but this is C style casting, this is C++ style casting, and this won't allow. I mean, this won't compile, whereas this will successfully compile. See, I have given the comment here, pass at compile time but fail at runtime. I mean, this might fail or might not fail. It depends what address it is accessing, is it allowed to access and all that. But this is a danger thing, and this is telling like it will fail compile time only. Okay, because both pointers are not compatible pointer types. Okay, so C++ cast avoid so many dangerous casting what C allows. Okay, so this was the third point. You will notice that this part was compiled. See, there is no error. The error is here. Invalid static cast from character pointer to integer pointer. This one, but this one has compiled successfully. So if you will comment this part like this, and we will go again and compile that, see, it has compiled successfully. Okay, whereas this is a big problem. So you got the proof. Now let's look at the fourth point. Fourth point tells it won't allow to typecast your derived into private base pointer. Okay, I mean, if you are using static cast, it won't allow, but if you are using again the C style casting, it will allow, and that is danger. I mean, that is not allowed cast, but still using C style casting you can achieve that. This is your derived class. You have inherited base as private. Okay, so let's compile this and you will get the error for that. See, base is inaccessible base of derived. Okay, because you are having private here. If you will write public, let's write public and recompile this. See, compiled, no problem at all. So if you will write private here, this won't allow your code to compile. So this was the fourth point. Let's look at the fifth point. I hope you are not tired of looking points here. So fifth point tells that use for all upcast but never use for confused downcast. So we'll see what do I mean by that. So here in this code, we have this base class. We are initializing base into derived 1 and derived 2. So this is something like this. Base, this is D1 and this is D2. So we have these two objects, derived 1 and derived 2. Now you are typecasting derived 1 object into base base pointer 1, and same thing derived 2 address into base pointer 2. So this is allowed because you are going from here to here, and in second case you are going from here to here. So we know that we can typecast it like this. Okay, so this is also perfect code, this is also perfect code. But the problem lies here. What you are trying to do is, after typecasting into upcast like this, you are again coming back. But while you are coming back from here to here, you are just switching. So base pointer 2, which was holding derived 2, is initialized to derived 1 pointer. Okay, see, derived 1. So now from here to you are again coming back like this and this. Now here you are initializing D2 and here you are initializing D1. Okay, so D2 is initialized inside D1 type and D1 is initialized into D2 type here. Okay, and this is compiling. So this point is not about where you should use static cast. This point is about where you should not use static cast. You should not use static cast if you don't know what your pointer is holding. So you might typecast it wrongly. Okay, so that's why I told never use for confused downcast. If you would compile this, this will compile successfully. Okay, see, and this is the problem. You can see that. So this should not happen, and you should use dynamic cast for that, and I will give a separate lecture on that. Okay, so this was 5th point. Let's look at the 6th point, and maybe that is the last point. Yeah, don't worry, you can go home, no problem. And 6th point tells that you should use static cast whenever you are casting to void pointer or from void pointer. So let's see what is that. So you got this I is equal to 10. You're typecasting address of I into void pointer. Then you should use static cast. If you are typecasting any void pointer to some another pointer like this, then also you should use static cast. Okay? Why? Because there is a predefined rule for converting anything into a void pointer, and that knows how to convert any pointer to a void pointer. Okay? Because this is generic pointer, so there is a standard way of doing this. And this is obviously a compile time check, so you should use static cast. Okay? So this is also a point here, and maybe I don't have any point. So let's look at the bottom lines. Bottom line says that for compatible type conversions such as float to integer, so you should use static for this purpose. We saw this in first point. Second point is for conversion operator and conversion constructor. We saw that in second point to avoid unrelated pointer conversion. We saw this in third point where we were typecasting character pointer into integer pointer. Okay? And fourth is avoid derived to private base pointer conversion. We saw this as well. And use for all upcast but never use for confused downcast, because there is no runtime check performed for static cast conversion, because static means it will be happening at compile time. There is no runtime check here. Okay? Runtime check happens with dynamic cast. We will see that in upcoming videos. And by the time you are watching this video, maybe it is already there. So check out the description field. And 6th point is intensor are more clear in C++ style cast. And 6th is finding is easy. Like if you want to find where you are doing all static cast, you can just easily find that. But in case of C style casting, it is nearly impossible unless you are using some kind of regular expression or something to find that. And maybe you won't be able to find that. And 8th is error finding at compile time. Yeah, if you are using static cast, it means you want to check everything at compile time itself. Okay, so generally experienced people tell that this is the first cast you should always go for. If it is not compiling, then think twice and go for other cast. Okay, so I think we're done here. So let's look at the next video, which is maybe about reinterpret cast or dynamic cast. I don't know. You'll get the link in the description field. I'll see you in the next video. Bye bye.
Previous video we saw how to use constant cast and static cast. So let's start this video. So why we use dynamic cast? Dynamic cast is used for only one reason, and that reason is this. You have a base class. There are derived classes D1 and D2. We all know that if you are creating a base pointer like this, base ptr, then you can initialize either d1 or d2 inside base pointer. Okay, so d1 or d2. But let's suppose you initialized d1 and after some point of time from this base pointer you are typecasting into d2. So d2 is equal to base pointer. We know this is not good because actually this base pointer is holding d1 data, but you are typecasting that data into d2 and this is wrong. So to find out this problem in your code, we use dynamic cast. Okay, this is the only use of this dynamic cast. Base pointer can have either d1 or d2. I mean derived 1 or derived 2 or derived 3, because there could be n number of derived classes. In that case, all classes what belongs at this level can be assigned to base pointer. But if you are getting back from there to this class, you might assign this data inside this data. Okay, so to avoid that problem, we use dynamic cast, and we'll see how we do that. So before going further, let's read some points so it will be a little easier for us. So dynamic cast is used at runtime to find out correct downcast. So that's what I told. This is called downcast. You did upcast and from here you're doing downcast. Okay, so note number 0 is you need at least one virtual function in base class. So in order to use dynamic cast, you must have a virtual function in your base class or your inheritance hierarchy. Okay, then only this dynamic cast will be able to find whether it is really the same object or not. Okay, so first point is, if the cast is successful, dynamic cast return a value of type new type. So new type is this one. So if cast is successful, like you are casting d1 into base pointer, and if this cast is successful, you will get this type of data. Okay, and third point is, if the cast fails and new type is a pointer type, it returns a null pointer of that type. So if this cast is failing, then this will have a null pointer. Okay, that's the note number 2. Let's look at note number 3. If the cast fails and new type is a reference type, new type is always this type. Okay, don't get confused. So if it is reference type, it throws an exception that matches a handler of type bad cast. So it means it will be throwing an exception of bad cast. Okay, there is an exception called bad cast we will get if we are typecasting into reference. So these were some points. Let's look at the classes now. This is the base class. We have derived base into d1 and d2. Now see, you are typecasting derived derived 1 object here into base pointer. This is a valid code, no problem in this code. Okay, now this base pointer is holding derived 1 object, but you are typecasting that base pointer into derived 2 pointer and assigning into this. This is not correct code. Okay, and this is where the dynamic cast comes. So what I said, if the cast fails and new type is pointer, it return null pointer. So as we know this cast will fail, we can just simply check that. So if dp2 is equal to null ptr, we can print something. Okay, null, we can just simply print this. Okay, so let's compile this code and see it is printing null for you. Okay, it means that this is not working. Okay, let's add else case also and print something else like not null. Okay, and if this is the case, then it is failing. Let's typecast to the perfect type like derived 1 itself, and we will see whether it is compiling or not. So let's compile and run this. See, in this case it is not null. It means you have got the perfect typecast. Okay, so this is the only sole purpose of dynamic cast. There is no other use. And don't forget, you have to use virtual keyword. Okay, so let's remove this virtual keyword and see the difference. So if you will remove this virtual keyword,
If you'll compile, it won't compile itself. The error is cannot dynamic cast base pointer of type class base pointer to class derived pointer. It is telling the same thing because source type is not polymorphic. So by adding virtual there, we make this polymorphic, and that's how we are able to achieve runtime checking. And what is that runtime checking? Let's read out this bottom line here. We'll understand it really good. Bottom line tells work only on polymorphic base class. At least one virtual function is required in base class because it uses this information to decide about wrong downcast. It is used for upcast like derived to base and downcast like base to derived, but it is mainly used for correct downcast. Okay, and using this cast has runtime overhead. This is also a very important point. Runtime overhead means it will check at runtime that the object you are really typecasting, like base pointer to derived pointer. So in this base pointer, what type of object is? Okay, so if it is derived 1, so you are typecasting into derived 1, yeah, then it is okay. So this happens at runtime, and you need virtual keyword there, and we all know why we use virtual keyword. Using virtual include runtime type information, and it uses that. Okay, so this was the main point. So let's look at the fourth point. If we are sure that we will never cast to wrong object, then we should always avoid this cast, and we should always use static cast instead of dynamic cast. And there is only one reason to not use this, because we have runtime overhead. Okay, it will be little bit slower than static cast. Static cast will also cast this one into this one, but it won't check at runtime. Okay, so you don't have that luxury of finding out at runtime that it is really typecasted or not, because the static cast is a compile time cast, and it will check, okay, base pointer and derived pointer. Okay, no problem, because base inherited into derived 2 or derived 1 in that case, so it is okay. But it is not okay if base pointer is pointing to some another object. Okay, and let's look at that reference case. I didn't discuss that, right? So let's create a reference like derived 1 reference r is equal to dynamic cast derived 1 reference and d1. Okay, so this is r1, and we will check this one with try and catch. So try, and after that we will write catch block. Here we will write std exception reference e, and we can just simply print that message. Okay, so our class is okay. Now we have to use that exception header file, include exception. Okay, and I think we are good to go. Yeah, it compiled, so we are not doing anything bad, so it is just simply compiling. Okay, so if you want to do something weird, you can just typecast into something else. So if this is d1, which is of type what? Derived 1, and typecasting into derived 2 reference, in that case it should throw an exception and we should come here. Okay, so let's see we are coming or not. And as we can see here, we are having this std bad cast. Okay, and there is one warning like dynamic cast of derived 1 to class derived 2 reference can never be succeeded. Okay, so we saw that how to use dynamic cast, and I think you enjoyed the video. So the next video is about reinterpret cast. I'll see you in the next video. Bye bye.
And in this video we'll be learning about reinterpret cast, and this cast is used for casting one pointer data type to another pointer data type. Okay, and it is a little dangerous cast, and we'll see why. So let's read out this one. It can perform dangerous conversions because it can typecast any pointer to any another pointer. Okay, so as you can see here, there is this banana and mango. And now I'm not forcefully actually, it is just a message to the compiler that now onwards you will be treating this address as banana address and this address is mango. Okay, so it's very simple message to the compiler that please trust me what I'm doing, I know what I'm doing, so please do what I want. Okay, so it will simply convert that. So if you will compile it, let's compile this, and if you are running, see it has compiled. Okay, and if you will run this, let's run this code and don't be surprised. See, eating banana. So actually you're having mango object typecasted into banana, and now you're calling eating banana, which is this one, and it is calling. Why it is calling? The reason is whenever compiler sees okay you're calling some function like this one on this object, so what compiler does, compiler just simply change this line into something else, and that something else will look like this: banana eat banana, and here the address of new banana will go. Okay, so if it is pointer, this will directly go. Okay, and let's suppose if you are passing some parameters like 1 comma 2, maybe it is taking some parameters here, then things would look like this, comma 1 comma 2. Okay, and now you'll be thinking that the type mismatch will come because here 3 parameters are there and here only 2 parameters will be there, like integer a comma integer b. But no, whenever you are writing something like this and giving declaration and definition like this, compiler changes your classes also. So compiler will make it look like this: const banana this pointer. So do you remember you always get this pointer in your class? So this is how you get it. Okay, I mean in your functions. Okay, and this is how you get it. So I think I'm going off topic, so let's come back and remove everything. And this was the first point I wanted to discuss, and first point is it is dangerous. You can see it is dangerous. Okay, right now we are not having any data member in banana and mango, so it's okay, otherwise it will be a really dangerous task. Okay, trust me. So this is where you should not use a reinterpret cast. Okay, and I mean obviously you should never be doing dangerous stuff in programming until unless you really know what you're doing. Okay, so let's look at the second point now. Second point is really very good point. I like that point. Why we use reinterpret cast, and this is the reason for that. Let's suppose you have some class or struct in C++, doesn't matter because the only difference is public. Okay, by default struct members and inheritance are public. That's the only difference. So this is your struct, we have the values here. Now let's suppose there is an API like this, or just forget about the APIs, you can do something like this: integer pointer p is equal to reinterpret cast into integer pointer and give the address of s. Okay, if we will compile this code is going to compile. See, so what we are actually doing is we have this s which is holding 1 2 3 4 4 bytes. So I'll draw a diagram for you, it will be a little easier for us. So as we know that this is a struct, this will be taking 4 bytes, this will be taking 4 bytes, and in conjunction these two will fit in 4 byte. Okay, and why 444? If you don't know what is structural padding and packing, please search in my channel, you will get that video for that, or maybe I'll include that in my description field, or you can search in YouTube. My video is only coming on the top. So let's draw this here. So we have one struct and 3 part. So this is from 0 to 3, 4 to 7, and 8 to 11. Okay, 4 bytes, 4, 4 and 4. In first 4 byte we have X. In second 4 byte we have Y. In third 4 byte, as third 4 byte is having these two and character can fit in 1 byte, so first byte of this will be a character, let's call that C here, and second byte will be boolean, so boolean, and rest of the 2 bytes will be empty. Okay, so this is how it would look like. So now come back to the code and try to print few things. Like if you will print this one P, let's see what answer you will get. You're getting 5. So what you did, you said, okay compiler, I want to treat this address as it is integer pointer. Okay, and now you're going to print that. So what ultimately it is trying to do is, this will start from here. So this is the base address, whatever the address is, let's call this a 0th address. Then this 0th address will be typecasted into integer pointer here. Okay, so if you will print that, compiler knows very well how to print a 4 byte memory. So it will come here, it will take initial 4 bytes, and whatever the value is on that 4 byte, it will just simply print here. Okay, now do one thing, you just increment it ++. Now you print, and you will not be surprised, I know, because it will print 10. So see, we had kept 5 and 10, so it is printing 10. Why it is printing 10? We know if it is integer has 4 bytes, so it will be incremented by 4 byte. So before it was pointing in the beginning of P, which is nothing but S, so before it was pointing here, now it is pointing here. Okay, so that's why if you are printing after P++, it will be printing 10. So up to now it was okay, but if you will give one more increment, you will come to this position. Okay, C and B position. So if you will try to print that, you will be surprised. Let's do this P++ and this print again. See, some value. Okay, 5, 10 were okay, but 2, 6, 2, 1 is not what we wanted. So what is happening here? The thing is, your compiler is taking full 4 byte because you are taking the help of integer pointer here. See, P is integer pointer. So if you are printing P and dereferencing that, it knows it is pointing to a 4 byte memory area. So compiler is taking 4 byte, full 4 byte from here to here, and whatever the value, bit patterns like 0, 1, 1, 0, 1, 0, 0, 1 it is getting, it will just convert that into integer and it is printing. So you end up getting this one. Now how to get that? So here comes the real beauty. You know that after this P++, you are pointing at this location. Okay, the beginning of this C. Okay, now you know this initial first byte is of type character. Okay, so do one thing, typecast it back to the character. So reinterpret cast char pointer and remove this one, and let's not do this, better character pointer C, and we can just print this by dereferencing this C here. Okay, now if you will run, see, you have got your A here. So this C was holding A here, we can see. Now if you want another pointer here, you have this character pointer, and if you will increase character pointer, this one, that will get incremented by 1. It means it will go to 9th position. Right now you are pointing at 8th position, 0 to 3, 4 to 7, then 8 to 12. So right now you are at 8th position. Now let's go to ninth position by just incrementing C. So C++. Oh, C++. And okay, wait a minute. Instead of doing all these things, we can just simply use this one. Reinterpret cast, character pointer, and ++C. Okay, it will give you 1. Let's check that. Uh-oh, it is giving you something else. Oh yeah, because that type is not character type, that is a boolean type. So let's convert that into bool type and then try to print. See, it is printing 1. So until unless we typecast it back to the actual pointer or to actual data type, you cannot use that properly. And that's what we saw here. Okay, so I think I have made my points. Now let's look at the bottom lines. We always got the bottom line. Maybe I have not included everything, I don't know. If I miss something, you please comment. It will be really helpful for others. Okay, so read out. Bottom lines are: the result of a reinterpret cast cannot safely be used for anything other than being cast back its original type. And we saw that here, okay? And we should be very careful when using this cast. Yeah, this is a very true statement because you might end up messing up with your stuff, okay? And if we use this type of cast, then it becomes non-portable. What is this non-portable product? Non-portable means you cannot take this project and run for any another CPU architecture, computer architecture and all that, because now here we are dealing with big patterns. There is no abstraction between hardware and software. You are directly going to access the hardware. You are going byte by byte. See here. So if your hardware is treating differently, I mean whatever the code you have written, your hardware can treat this differently, okay? And the difference could be, I don't know, let me tell you that. Here we are having 444. Your hardware, I mean whatever another architecture or what you are using, that can take 4 bytes, okay? And if you wanted to access this boolean, you would have done like this, but in this case you will end up accessing some garbage value which will be coming from somewhere around here, okay? Because this is x, this is y, and here in first byte C, second byte boolean, sorry, boolean is not here, boolean is here. And in our previous code like this, you were thinking boolean is here, okay? So mismatch happens like this in hardware side. So that's why this reinterpret cast is not good when you plan for porting your project, okay? So we have almost completed our 4 cast, like static cast, dynamic cast, reinterpret cast and const cast. Now I was planning to give the difference between all cast, like what is the difference between static and dynamic. So if you will know the difference, you will directly decide where to use what, okay? But that would take a little time because that was not in my schedule, okay? So we'll see the differences in upcoming videos. Bye bye.
And in this video, we will be learning about constant cast in C++. So we all know there are 4 types of cast available in C++: constant cast, static cast, dynamic cast, and reinterpret cast. So first we'll see this one. In later videos, we'll be looking into all those casts. Okay. So this is a little bit of note. I will be discussing 2 points. This is first point and this is second point. And lastly, we'll be discussing about the bottom line. So let's start this. So first to read this note here, the expression constant cast can be used to change the constant or volatile qualifier of pointers or reference. So we all know this is the syntax of typecasting. So see, you can typecast const cast and this is the syntax for that. So this is the destination type and this is your source. So what this line is telling that your source should be either pointer
or reference. Okay, and where T must be a pointer, reference, or pointer to a member type, whereas this one, this T should be either pointer or reference or a pointer to a member type. Okay, only these type can be converted using constant cast. Okay, so let's see what is first point. The first point tells when the actual referred object or variable is not const, then only use constant cast. What it does, it removes the constantness of your variable or pointer or reference. Okay, so this is the first case and this is the second case. Both are exactly equal. The only difference is this variable is constant here. Okay, you're creating a constant variable, you're taking the address of that variable inside another constant integer pointer. So this is okay. Now what you're doing, you're removing the constantness from here so that you can ultimately change this variable. Okay, that's what we are doing here. Got it? And now we are changing that variable. And the comment says invalid and undefined behavior because there is one variable. This is a constant variable. Now you have taken the address of this variable. So let's suppose the address is f and f into some another variable, and this variable is a1, and this will be b1, and 0 cross f and f. Initially you told that this is a constant variable, okay, with this. Now you are removing that constantness and trying to access this memory address by this one. So you're dereferencing this memory address and you're pushing the value, whereas the original memory, which is this one, is constant. So this case is totally invalid and undefined behavior situation. Okay, you should never use something like this. Even though it is allowed, I mean, it will compile, but you should not do that because this type of situations are invalid and not defined in C++ compiler, so you might get some weird result. Okay, so let's see where you can use this constant cast. This is the situation where you can use that. See, the original address is not constant, so here it is like this. You have this a2, and let's suppose this is ff0. This is not constant. You are storing this address somewhere here, 0 cross ff0 into b2, and you're trying to cast away the constantness of this pointer, which is this one, and dereferencing this operator, I mean the address, and you are changing this a2 itself. And this is a valid code, and you can do that because the original address is not constant. Here original address was constant, so there was a problem. Okay, so this is how we do this. This is the first case where you will use such things, I mean constant cast. This was the first scenario. Let's look at the second case, or before going to that case, let's compile this. See, it has compiled successfully and there is no error in this. Now you guys might be thinking that what actually it will print. So let's print that. So if you have printed a1 and if you have printed this dereferenced d1, then what would be the value? Okay, let's see that value would be a little shocking for you, I know that, and I will demonstrate why it is like that. See, a1 is 10 but d1 is 15. How is it possible? If the underlying address, which is this one, is equal, so how this one address is holding two value like 15 and 10? How is it possible? How is it happening here? No, it is not like that. Actually, what happens when you have defined some variable a1 as a constant, compiler will try to optimize your compilation, and instead of a1, when you are compiling, your compiler will directly write this value here. So instead of a1, it is writing 10 here. And this d1, what you did, ultimately changed this address. Okay, and instead of 10, now a1, which is this 0xFF address is actually holding 10, okay, not 15. So that's why you are getting 10 and 15 like this. And I think we understood this first one, so let's go for the second one. Second one tells you use constant cast for this purpose. When we need to call some third-party library where it is taking variable or object, whatever you are passing, as non-constant but does not change that. What do I mean by that? Is this code. You have this constant variable. You have pointed out that constant variable with a constant pointer. Now there is a situation that there is this third-party library. Actually, in third-party library, you don't have the definition, you just have the declaration part, and you just include the library so that you cannot change that. Here you can change it, but in actual third-party, you cannot change anything. Okay? Like in C, if you remember, there is a sorting function qsort. That function parameters are fixed. You cannot change that. So the same way you cannot change this one, but I don't have any option, so I'm just taking this to demonstrate that. So the situation is you're having constant variable x, you're a constant variable, the pointer variable of that x. Now you are holding this one right now. And the situation is you have to pass the value to third-party library where it is not taking constant integer pointer. It is just taking integer pointer. But you have a constant integer pointer. And if you are not using this one and passing this px, which is a constant, to non-constant, it will throw an error at compile time. So I shall just simply remove this, and if we will compile it, it will throw error. See, it is telling that invalid conversion from constant integer pointer to integer pointer. Okay, and if I will use that, now let's again compile that. See, it has successfully executed and the answer is 30. So you will use constant cast when there is some situation like this. Your third-party library is non-constant and your data is constant, so you will cast away that constantness from your data and you will send that. Okay, but yes, that library should not change that data, otherwise it will become undefined behavior, what we learned in the first point. Okay, see, it is not changing, it is just taking the value at that address and adding with k. Okay, so ultimately it is become 30. We saw that. So this is the second case. I won't be showing the situation where it can remove the volatile qualifier. You just assume it removes the volatile qualifier because this volatile is generally used in embedded systems where you don't want to optimize any variable. You tell to the compiler that please don't optimize this variable, and sometimes you want to remove that volatile type from the variable and you want to tell that okay, now you can optimize that variable. Okay, so that was the second point here. Now let's look at the bottom line. Bottom line says that never use this because it will compile, as we saw that in our previous first case. See, this was executing but this was undefined behavior. Okay, so you might think okay, it is working, so it is allowed, but it is not allowed actually. Okay, so never use until unless you have to use it. Okay, second point is use only when the actual referred object or variable is not constant, that we saw in first situation. Okay, and third point is use when we are dealing with third-party library and some API wants some data non-constant form, but we have it in constant. That also we saw in our the second point. Okay, so to recap that, constant cast removes constant or volatile qualifier from the variable, and what you are typecasting should be either pointer or reference, which is this v here. So this is the source, what you are typecasting, and what you are typecasting into, that should be either pointer or reference or a pointer to a member type. Okay, and constant cast should be avoided until unless you really need to use that. Okay, so I think we're done here. Let's look at the next video about static cast, and link is given in the description field. Bye bye. And in this video we'll discuss how to return two-dimensional array from function in C and C++. So there are basically 3 ways to do that. First is using dynamic array. Second is using a static keyword. You will be creating the array statically. Okay, and third is using a struct technique. So we'll discuss one by one. So this first one is a using this dynamic array here. So how we create dynamic array, 2D dynamic array, that's the whole technique here. So this is the whole program. We have this main here. Main is having this double integer pointer. We're calling this getArray function. This function here, we're creating 2D array like this. So I'll tell you what is the meaning of this line here. This line here is telling that, okay, I'll be creating n number of integer pointer array. So n is nothing but 3 here. So we will have 3 pointers. Okay, so this will store integer pointer. The address of integer. Okay, and after that, using this for loop, we are iteratively inserting integer of n's. So integer of 3. So this is like this. You have this 3, this 3, and this 3 arrays here, and you are putting this inside this. The initial address of that. Okay, so this is what happening here. So this line is creating this one, and this line is responsible for creating this one, and this one. And why it is creating 3 times? Because it is in loop, and we are running from 0 to n, which is 3. Okay, that's why it is created 3 times. So this is how we create a 2-dimensional array dynamically. So when you will access it like this, array of I, let's suppose this is 0th here, this is 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2. Then in this case, if you are accessing 0 means this one, and 0 means this one. So if it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 0 means this position, because first 0 is this one, second 0 is this one. So this is 1. If it is 0, 1, then first 0 is always this one. If it is 2, 1, that means 2 means this one, 1 means this one. So it is 8. Okay, so like this whole dynamic array creation work. And why this dynamic array thing will work? We are creating this as a pointer, and we know that pointer doesn't get created on the function stack. The real problem we are dealing with array returning is, if you are creating array here in this function and returning that, we don't return the array, we get the address of that, and once this function will get destroyed, that array will also get destroyed. So if you are not sure what I'm talking about, please go and watch my previous video which tells that how to return one-dimensional array. There I have explained what are the complexities in returning arrays. Okay, so this is one of the way here. I think this whole code is pretty much clear because I have written in such a way that there won't be any issue. Okay, so this is the function call here. You are calling this function, you are creating the array. First line will create this one, and these for loops will create this one, and this for loop will fill the data inside that. Okay, so it doesn't matter what data you're filling, and after that you're just returning that array, okay, with this double pointer. And this is the syntax of doing this. Okay, so let's compile this and check whether it is compiling or not. See, it has compiled, and the answer is 0, 1, 2, 1, 2, 3, and 2, 3, 4. So this is what I inserted inside that. So that's what we are getting here. And if you are watching for C, just replace this line with printf. Okay, printf d array of I, j. Okay, and you're done. There's no issue in this. And you will have to remove this using namespace in iOS stream, but the code will be similar. Okay, there is not much change. You won't be having this return 0, but that also doesn't matter. The whole idea is, from where you want to return the array, create it dynamically, and this is the way of doing this. Note it down. Okay, so let's move to the next point, which tells that using static keyword. So let me replace this whole code here, and this is the code for that. And this is something you might find a weird one. Okay, we are doing everything similar but not exact similar. Before, if you remember, we were having this as a double pointer, but this time if you really want to get return an array, not as a pointer, and please remember, arrays are not similar to the pointers, so they are total different things. Okay, so before we were dealing with the pointers, that's why we were returning double pointer, and that was making sense, and everywhere we were using double pointers and things was good. And this time we'll be dealing with the arrays. You will be returning array, literally array. So this is what the syntax is. And if you want to get array into your pointer, this is what the syntax is. Okay, so this is how you will create a pointer which will hold n number of arrays. Okay, and this field has to be there, and this should be a constant value. Okay, so this is how you do this. Get array will do the same thing. Get array is this function, and yes, this is the syntax of writing your function which returns 2D array. It is looking very weird, but it is really very simple. But there is a technique, type def. There you can use, define the type. Like suppose you are defining a type like double pointer. Okay, and this is what it is. After this, you have to keep this one as a type. So now your life will become easy. Okay, and you're done. See, compile this, and it is working fine. Okay, so what you did, you created a type by saying that, okay, this is a pointer of an arrays. Okay, and why static int is working here, I have already discussed in previous video that the static is created at global scope and it doesn't get destroyed when you return from this function. Okay, so it will be there. That's why you are happily accessing here. I recommend please watch my previous video which tells about how to return one-dimensional array. There I have discussed so many things, and that would be clearing your doubt so much. And the last one is using struct technique. So let's look at that. So this is what the struct technique is. You will be wrapping your array, whatever you want to return from some array, inside some structure. Okay, like this, and just simply create the variable of that structure type and fill that array and simply return that variable and keep that type as a structure type, and that is perfectly fine because here it is written by a value. Okay, so array element will get copied one element by one element here. Okay, you can do this with classes also. I have taken struct because maybe those people who don't know C++ might get confused here. Okay, so this is the third technique. Let's compile this and check the working of this one. Yeah, see, this is also working. Okay, so this is really very simple. You are creating a structure, accessing that array inside that, and just populating it and just returning. After that, we are just simply getting it, sending it to print. We are printing it. Everything is okay. So this is one of the coolest way to do this. But when your array will get bigger and bigger, then this return here will make problem for you because it is a copy of your all the elements from this variable to this variable. Okay, that's why generally we don't prefer this, and we don't really use this returning array thing. We generally, what we do, we create the array here itself and we'll send the address of that here and we will populate that array here. We don't create array and populate here and just return that array. No, we generally don't do that. So this is all about returning two-dimensional array. Thanks for watching.
And in this video we will be looking into this union in C++. There is no difference between union in C and union in C++. Actually, there are few rules when you create union and inside that you have some objects, but this is a very basic video. I won't be covering all those things. So these are the notes. Just like structures and classes, a union is a user-defined data type. So classes and structures, user-defined data types. So similarly, union is also a user-defined data type. You will write union just like you used to write some classes and structures. But there is a very big difference that we'll talk now. So the second point is, in union, all members share the biggest same memory location. This is the key point of union. So let's create a union, then we'll talk about this one. The union creation goes like this. Union is a keyword, then you give the name. So I'll just give my union and semicolon, and here you give the data members like integer x, short y, and character c. So This is how you give in classes and structure also. But in union, you don't have any constructor, destructors, nothing. You just define data members and that's it. So now let's talk about this one. So as I said, this unions, all members share the biggest same memory location. So you know this integer will take 4 byte, sort will take 2 byte and character will take 1 byte. So which is the biggest element, data member inside this? This one. So what will happen? Union will create only one memory like this, and let's make it 4 bytes, and this XYZ, all data members will point to this only. This is the key point of this union. What will happen? You will create union will see which one is the biggest one and it will create one memory for that. Okay, so integer was 4 byte, so it created 4 byte and everyone is pointing to that byte. That's it. Now you might be thinking, what is this? What is the use of this one? So we'll see all those use cases. Wait for some time. So you understood how this will behave. Okay, so biggest element memory will be created and everyone will point to that. Okay, so now let's move to the next one. This is used to achieve polymorphism in C. Yes, if you remember polymorphism, maybe you don't know what is polymorphism, then let me tell you that polymorphism means similar name but different work. Okay, so it will be like different work or different functions, I can say, but these functions will have similar name, and that is called polymorphism. And here also, can you see there is only one memory and everyone is pointing to that memory only. So this is how we achieve polymorphism in C. So let's recap this quickly, then we'll go for the use cases. This is the keyword for making union and the name of the union. Then you type as many data members you want inside that, and it will take the biggest data members size and it will make every different data members to point to that memory only. Okay, so this is what union does. Now let's see the use of this one. So you might be able to understand this, like if it is having so many members but still creating the biggest one only, then the maximum size of this union would be the maximum data member size, right? So here, if you will get the size of this one, it will be 4 bytes. If it would have been a class or structure, it would have been like 4 to 1, and the structural padding will come, so it will become 8 byte, not 7. If you don't know what is structural padding, I have a video for that. But that's not the point. The point is union will be 4 byte only. No matter how many data members you have, it will take only the biggest size. So you can see here you are saving so much of size here. So that's the first point. When we need only one value out of many, that time we will use it. It means there is a situation like you have to create so many data members, but at a time you will be using only one. Okay, so no need to create different data members. Like when you create classes and structures, you have different sizes, but that is wastage of memory because only one is needed at a time. This is the example. Here what is happening is I have created a union square and given two integer, width and height. So you might be knowing what is square. Square means like this. The height and the width will be equal, a square. Okay, so I have created a square class. So if width and height both are equal, then why we need to take two different data members? So that's why I have achieved this using only this width. So either you set only width or the height. So this is square, so as I said, it will be choosing the highest one. So both are equal, so it will take 4 byte memory, and width and height both will be pointing to that memory only. Now let's create the object of this union. So sqr is the object and I am setting width is equal to 10. So ultimately I am setting height also. Now what I am doing, I am getting this get area. So the area of square is width into height. So I am sending square dot width and the height. But here I have not set the height, but as I said, height is also pointing to this 10 only. So it will go and get multiplied. 10 into 10 will get 100 here. So let's compile this. See, we got 100. So this is a perfect code. I couldn't find a better example for this, but I think I made the point. The point is, when you don't need several data members, but it is quite logical to have those members, because if you are making square, then you cannot have only width, right? Or only height. You must have both. But here the situation is what the value of width will be, that is equal to the height. So no need to take two data members. It will make your size bigger. So these kind of situations are handled using union. This was the first example. I'll show you the second example also. That is a very nice example. Actually, there are so many examples. If you'll Google it, you will get it. But my job is just to convey the message. So here what we are doing is we are having this 4 bytes, and as usual this is 0, 1, 2 and 3. Actually it depends how your memory is reading the addresses. In my system it is reading from here. Okay, so if you are initializing 2, it will go here. So as this is 8-bit location, it will be like, I will write it here, 0, 0, 0, 0, 0, 0, 1 and 0. So 2 is this one in the binary. Okay, so this is going to this one and the rest of the values are still 0. So everything is 0, 0, 0, 0 inside this. Okay, now let's suppose the requirement is you just want to read the first byte of your value. Then this is a very handy way of using that. Okay, what you can do, you can just simply read the byte number 0, and we have to typecast it into integer, otherwise it will show you the character at second ASCII. Okay, so wait a minute, let me just typecast that. So let's compile this one. See, it is giving you exact thing what we were looking for. 0th location is having 2, rest of the values are 0. So this is what we saw here. Okay, so you have this integer value and you want to access it byte by byte, not full. So as you know that character is 1 byte, so if you will read this byte's 0th location, it will read only 1 byte. Now it depends what location you want to get. Okay, so this is also a very good use of union. Okay, so just keep your main data and create that much big character array and you will happily use this. Okay, so let's just change something. If you will make this 257, so you must be getting this one as 1 and this one as 1. Okay, so let's check that. If I'll compile this, see, you are getting 1 and 1. So 256 means there are 8 bits here and the last bit is 1 here and this is 0, and there are 8 bits here, so there are 7 zeros, 0, 0, 0, 0, 0, 0, 0 and 1. So this is your 257, but as we are reading only byte by byte, so this is only 1. Okay, and this is also 1. That's why we got 1 and 1. So it's great fun, right? You don't have to go and fetch bytes explicitly. You can use this technique and it will work really great. These kind of techniques are not so common. People use these kind of things in embedded because there you will have so much of problem in memory side. You will be having very less memory and you have to work with it. Okay, so they keep track of memory so much. So that's why if you are an embedded developer or you want to become an embedded developer, you should be mastering this union, or you can expect this union question in embedded interviews a lot. So I think we're done here. Thanks for watching. And if you did like the video, don't forget to hit the like button. and make sure you subscribe to my channel so that whenever I will create a new video, you will get the notification for that. Okay, so thanks for watching. Bye bye.
And in this video we will see how to return an array from a function in C. Okay, so this is our program here. So this is your main function and you are just calling this function, and in this function you are returning this array. This array is of 3 size and 1 to 3 are the values. Okay, and returning this array. This is integer pointer. Arrays are type of pointers, so this is also good. We are getting in integer pointer and we're just simply printing 0, 1 and 2. So this code is looking good, but it is not going to compile because there is a problem. Okay, I mean compile time warning is there, but it is a runtime problem. Why? Let's see that. So first of all, let's compile this program. So I have compiled it and it is telling that this exe has stopped working. Why? Because you're calling this function here, we are coming here, we're creating an array, that is also okay, you're returning array, that is also fine, integer pointer, that is also fine, everything is fine here. But the problem is you are returning this array which was created inside this function here. But if you remember, I mean if you have watched my previous video, I have already told that if you are returning from a function and that function has some local variable created inside that, so once you will get out of that function, that local variable will be destroyed. So this is our local array. So this array is also going to get destroyed. That's why you are not getting that array here. Even though it is kind of pointers and all, but it will get destroyed. So one thing you need to keep in your mind that you should never return any local. Okay, if it is returning this array and every value is getting copied one by one here, then it is okay. But that is not the case. You are just simply returning a pointer here, and this array will point this array, whereas this array is not there. Okay, so always remember, returning pointers of local and returning references of local are not good idea. Okay, so let's see how to achieve this. So we have studied the use of static keyword here. This was asked in one of my friend's interview and he couldn't give the right answer for this. He told me that okay, I was returning like this, and I was like, oh my god, you did this mistake, and he was like, oh. So watch this carefully. They might ask you as well. So static keyword use is like whenever you create anything with static keyword, that memory is not gonna get destroyed until unless your whole program is getting terminated. Okay, so this is kind of a global memory, okay, which will get created and will not get destroyed. So inside function you create a static array and you return that array like this. Everything is okay now. So if I will compile this, let's compile and see, you got the answer here, 1 2 3. Okay, as expected. The only problem was this array was getting destroyed. So one of the ways is make that array static and you are good to go. Okay, there are other things with static, like if you will call this function again, then this line is not going to get executed. Then only it makes sense, right? So we will not discuss all those parts. Our main point is how to return arrays. Okay, so this was first way. Second way is create array dynamically. So let's do that. In order to create array dynamically, you will be doing like this: new integer of size 3, and let's initialize this array. Array of 0 will be initialized with 1, array of 1 will be initialized with 2, and array of 2 will be initialized with 3, and we're just simply returning this array. Okay, so let's compile this as well. See, this is also compiled and running successfully. Okay, and why this code is working, we all know whenever you use this new operator or malloc operator, this goes to heap. Okay, this memory is not created inside the stack of the function. Okay, this will get created in heap, which is another kind of a global memory. That's why you're just returning the address of that memory from here and accessing here. So that is totally fine. Okay, in order to understand this little better, let's draw some diagrams here. Let's look at the way this program will run. So first of all, the running will start from here. So in that case, and we all know if you are creating a function, it means you are creating a stack. So let's suppose this is stack and it is growing this way, and you call this main function. So this main function address will reside here. Let's suppose this is a 0 cross 0, and here it is our main. Okay, and this much memory was allocated for main. Okay, let's suppose from 0 cross 0 to 0 cross 2 or something. Okay, then this main is calling this function. So this function will be residing on top of main like this. Okay, so this is our function stack. Here you're creating this array of size 3, but this memory is a byte addressable memory. In that case, 3 into 4, and 4 because you are having integer data type. So 4 cross 3 is equal to 12. So from 2 to 14. Okay, so 0 cross 14. So this is total 12 bytes of memory. Okay, here your array will reside. Let's suppose you're having this array like this. Okay, but when you're returning from here to again inside main, then this whole thing will go. Okay, so whatever this array you created here, this will also get destroyed. Okay, but let's suppose you didn't created this array on top of stack. You created it like this. I mean, using the heap memory, using this technique. Okay, so in that case, you will be holding a pointer of array, which is nothing but the address of some memory here. Let's call this a global or a heap memory. Here you will have 12 bytes of data. Okay, and this starting address, let's suppose this starting address is 0 cross 15. Then this 0 cross 15 will be assigned inside this array. Okay, and you're just simply returning this array here, which is nothing but you're returning this 0 cross 15 from here to here. Okay, so as I told, if you're coming out from here and going here, this will get destroyed. But notice this, you didn't create anything, so there is no problem, and you can happily use this array here because this memory is created here. Okay, and now it's your responsibility to delete this memory. Okay, and as this is an array, the delete sequence is actually, I have not created that delete sequence. So to delete that, you will have to write something like this: delete keyword, delete, and this bracket, and write the name of your array, which is ARR, and semicolon. Okay, this is the syntax for writing delete on array of pointers. Okay, so I think we're done here. In next video, we will see how to return two-dimensional array. This was one-dimensional array, C. Okay, and here we return one dimension. In next video, we'll see how to return two-dimensional or n-dimensional array. Okay, keep watching. Bye bye. And in this video, we will see what is function overloading and what is function overriding. Okay, so let's start with function overloading. In order to tell that two functions are overloaded, their name should be equal. Okay, but the parameters should be different, like this is taking integer and this is taking double, right? So we can say these two functions are overloaded. And if you will call print with 5, this 5 is an integer value, so this function will be called. And if you will call the same function name with a floating point numbers, then this function will call. Okay, so let's check that quickly. If I'll compile this, it is telling integer function 5 and double function 5.5. So first we are calling this one print 5. In that case, it is calling integer 1, and for the second case, it is calling this double one. Okay, so let's talk about this little move. So let's suppose you want to call the same print function with some character like a, and let's create the function for that. So that would look like character a, and we are just printing that char function and the value a. Okay, so let's compile this. We will see that it is calling character function, which is printing a and after the integer 5 and double 5.5. So this is how this binding happens, and this binding is called a compile time binding or a static binding or early binding. And why it is called binding? You can see that this is bound with this one, okay, and this one is bound with this one, but their name are same, right? So how they are bonding? They're bonding with the help of parameters. And one more thing, you can do something like this. If you are having one print function with one integer value, let me clear this, and there is another print function with two integer values, then also that is overloaded, okay, something like this, integer a comma integer b, okay, then also it is overloaded, because it will come to know that okay, there are two values for this function. So if you want to call with, let's suppose 5 and another print with 1 and 2, 1 comma 2, then in that case this function will be bonding with this one and this later one will bond with this one, okay. But here is one very important point to note, that function overloading work with the parameters like these things, okay, not the return type, okay. So it is not like you are keeping this one and like print a and print I. In that case both are taking one integer value. In this case there is a ambiguity, okay. Let's check that. If we'll compile this will give so many errors, okay. So these are the errors. I don't want to see that because I know there is an error, and that error is telling that, dude, I am compiler and I am really confused in this case whether I should call this one or this one, because both are taking integer values. And if you will change this parameter, let's suppose you want to return something from here, okay, in that case this is a problem. Why? Because it is not the return type which is considered in function overloading, it's the parameter what we are passing in, okay. Either you have to change the number of parameters you are taking, or you change the parameters itself, but this return type will not affect anything, okay. So if I will compile this, it will again tell me the same error, okay, ambiguating new declaration of integer. So it is an ambiguous call. Compiler is confused, okay, even if it is integer and void here. Got it? So that was the restriction on function overloading. And yeah, in order to overload the function, these two functions should be in the same scope. And I know most of the guys know what is scope, but still I'll tell. Scope means the boundary, okay. So this print and this print both are in this boundary. This is starting curly braces and this is end curly braces. So these two are in one boundary. These two functions are also in global scope, okay. But function overloading will not work if both are at different scope, okay. So we have studied function overloading, and yeah, one more thing is left. How compiler achieve this? How compiler will know that I'm supposed to call this function over this function or vice versa? Actually what it does, it changes the name. See, you have written like this, right? So what it will do, it will add some dummy name to this name, like print 01. Here it is print 02. And in first case, let's suppose you are taking an integer, and second case you are taking character here, okay. So it's like you are taking character, and let's remove this return and let's keep it void, okay. So in this case, if you are calling it with a here, then as you can see this is going to get bound with this one. So print 02 will be replaced. I'm telling you guys, this is going to happen, and I mean this is what happens when your compiler compile the code, and this technique is called name mangling. So this was all about function overloading. Let's go to function overriding here. So this is the example for function overriding. So we have a base class, we have a derived class, we have inherited base into derived, and both are happen to have the similar name functions. Like print is there in base and print is there in derived. So what will happen in what case? Let's see that. So first of all, we'll talk about why would you give the same name function if it is already there in base. Because inheritance tells that, okay, I am derived and I want base functionalities and base property. Okay, that's why I'm inheriting it. So if that is the case, if you're getting everything from here to here except constructors and few more things, but this function will come here, okay, but still you are giving that function again. The reason behind that is sometimes what happens, you are taking that functionality from base into derived, but you know what, you have your own definition for that particular operation, and in that case this print is one operation, and you might be willing to give the definition of this print differently than it is given in the base. Okay, so what you will do, you will write your own print function, and this will get the opportunity to override this function. Okay, so to simplify this, let's assume like if you are inheriting base into derived, then what compiler does, compiler will copy this one here inside derived. Okay, for simplicity please think like that. But if you already got the definition which is the same print function, then compiler won't do that. Okay, and why you would write the same function, I already told you. Maybe you want to give a different definition for the same function. Okay, and if you want to see the example for that, there is a very simple example. Let me write that code. So this is the code for that. Let's assume you are having one class as person, okay, and you are inheriting that class into a man class and a woman class, and there is a function in person like print name, but a man has its own name, okay, and woman has its own name. So if you will call print name on man object, then it will print its own name, okay, and if that is the case with woman, she will print her own name. Okay, so this is the example I have taken here. So let's just compile this. See, first it is printing person, Sandhya and Rupesh. Okay, so in this case what you did, you were inheriting person in man and woman, and you are overriding print name by giving your own method. Okay, and in order to achieve this, your function name should be equal and parameters should be equal. Okay, and in function overloading case, your function overloaded because of the parameters here, but in this case your return type will also matter. Here return type, whatever you did doesn't matter. The overloading was happening on the basis of this one, okay, parameters, what parameters are being passed. But in overriding, it will take return type also into the consideration. Okay, now wait a minute, there is a very important point I need to discuss here, and that point is, we all know how dynamic polymorphism work. Okay, and this is the code for that. If you have a parent class pointer, and let's suppose you are initializing it with the child class, this man is a child class, and now if you will print name, what name it will print. Now this is the different case than the previous one. Previous one, P was holding P object, okay, but in this case this is a person pointer which is holding man object. Okay, so in that case what will happen, is it going to print this one or this one? I know it will be printing this one only. Why? Because this is a static binding. Okay, this is early binding. So what it will see, okay, this pointer P is of person type, so print name will come from person. It won't check what is the object there inside this P. Okay, otherwise it would have given this print name. Okay, so let's compile that. If you will compile, there is some error, I guess. Write man m, and we can initialize the address of m. Okay, now compiling, it will print person as we expected. Okay, So how to get rid of this? I mean, even though pointer P is pointing to the main object, but it is still printing its own function. I mean, it is still calling its own function, not M function. Okay, logically it should call M function, because if you will call like print name here on M, then it will call its own function, which is this print name. Okay, so let's compile that. See, it is calling Rupesh and person. So here this one is calling the correct function, but in this case it is not calling the correct one. And the reason is we are not using a virtual keyword here. If you use virtual keyword here, then comes the runtime polymorphism, and this call will be resolved at runtime. Okay, so it will check, okay, I'm a pointer of person, but I'm holding object of M. Okay, so I should call this function, not this function. So let's check that quickly. See, in both the cases it is calling Rupesh. Okay, and there is a new keyword in C++ to verify whether you are really overriding something or not. Okay, and that is how I write code, because sometimes what happens, you think, okay, I have overridden this function into my function, but you did a small mistake, like you are not keeping the return type similar, like integer, then it won't be override. Okay, or you wanted to give print name as this one, instead of that you give print name, but you miss that E here, and that is very much possible. And you was thinking, okay, I'm happily overriding it, and see, you compile the code and it is compiled and it is running. So you will be thinking that my code is running, but why am I getting parents function call in this case, even if I have used virtual here? See, virtual, okay, but still I am getting parent. I should be getting child, right? So for that case only this override keyword is there. So if you will write override, then it will check, is there any function with print name in its parent class? No, it is not. So it will tell that you are overriding, but I am not overriding anything. So let's compile this here. So see, it is telling that mark with override, but doesn't override anything. Okay, so this was all about function overloading and overriding. If you have any concerns, please comment. We will discuss there. Thanks for watching.
And in this question, we'll be learning what is the difference between reference and the pointers in C++. So sometimes we use reference, sometimes we use pointers. So first is memory address. When you create a pointer like this, let's suppose you are creating an integer pointer P, and you are storing the address of I inside that. So here we are creating a reference here, and here we are creating pointer. Okay, so what is the difference between these two? So first point tells that P has its own address. Okay, so let's print that, like we'll print the address of R first, and we'll give one space here, and then we will print address of P. Okay, then we'll check whether it is really working or not. Okay, so let's compile this and see, there are two addresses, but this R and I are having equal address. I mean, both are sharing the same memory location. It's just an alias, like you are referring I, and that's it. Okay, you don't have your own address. Okay, so if you will print I address here, address of I, and let's give some space here, and we'll compile this, we'll see that this one and this one both are equal. Okay, see, so here comes the first point. Memory address is not given to the references, okay, because it is referring to this address only. Okay, actually what happens when you create a reference? When you create a reference, the symbol table is getting created in computer for all the variables, and the memory is allocated, like it is allocated for I. What is the size of the memory allocation? 4 byte, and that address was returned. So there will be one table which will hold the variable name and its address. So if you are accessing that variable name, ultimately you are accessing that address. Okay, so this variable and this variable both are pointing to the same memory location, but in
pointer case, it is not true. Pointer holds its own memory address. And let's see what do I mean by that. So whenever you are having these variables, it will create one table, and that is called symbol table, that generally look like this. There are lots of entries in that. I will be showing only 2 entries, so it will be very simplified here. So we are having this I, okay? So this is the name of your symbol, and this is the address part. So whenever you are creating any variable, it will have its address like 0x20. So this is the address. And if you are creating a reference, in that case, this will get copied directly here. Okay, so 0x20. And if you are getting any pointer, then it is like this, 0x something like 30. This 20 and 30 is not the point here. The point is these two memory locations will be equal and this will be different. Okay, so this is how this whole thing is working, and we have seen this memory address. So the second point is reassignment is not possible with reference. And let's see what do I mean by that. If you will write r is equal to, let's suppose something else, var, and you are having this var like this. Let's suppose it is holding 90, and you want r to point var, okay, not this I, but it is not possible. This will compile. The only thing will be this 90, what this variable is holding, will get assigned to r, and r is referring to I, so ultimately I will become 90. Okay, but if it is pointer like this one, this integer ptr, no, here it is only p. So if you want this p to hold some another address like var, this will hold the address of var. Okay, before it was holding the address of I, now you can reassign. Okay, and if you will dereference p is equal to, let's suppose 60, okay, then this 60 will get assigned to the var variable, not I. But in case of reference, you cannot do that. Once you have created a reference, you cannot change by saying that, okay, now I want to refer something else. No, it is a tight bound, you cannot break it. Okay, so that was the second point. Third point is null value. So let's see what do I mean by null value here. Whenever you create any pointer like integer pointer, if you don't want to initialize anything inside that, you generally initialize null to that, okay, like this. But that's not the case with reference. You cannot make it like this, and after some time here somewhere you are assigning I to R. No, that is not possible. You cannot have reference empty, or you cannot initialize it to null. Okay, so the second point is, this third point is, you have to give the variable name to the reference whenever you are creating the reference like this. Okay, but that's not the case with pointers. You can create pointers here and you can assign it anywhere. Okay, like p is equal to address of I, and that I could be somewhere here. Okay, integer I is equal to 10. So this is not possible and this is possible. So third point was, you cannot initialize null to reference, and you cannot make reference empty and initialize it later. No, you have to define what you are referring when you are creating any reference at the same time. And the fourth point is arithmetic operations. So let's see what these arithmetic operations are. Fourth point is that arithmetic operations are not provided for references. Okay, and let's see what do I mean by that. If you want to increment your pointer, so what generally we do, we write like this, p++. Okay, so it will point to the next memory location, but that is not the case with R. Okay, so references cannot point to something else. The only possible way to do that is you can have the address where it is pointing, and then you can increment that address by 1 or by any number. Okay, but this will not do anything. Okay, so that's the difference in terms of arithmetic operations, and that is not a very big difference. Okay, and last is indirection is not given in references. Okay, and let's see what do I mean by that as well. That is something like you have the level of indirections in pointers, you create double pointer like ptr, and inside that you will initialize your p. So this double pointer will hold the address of single pointer. Okay, and let's suppose you want to create a triple pointer. Okay, ptr1, that will hold the address of ptr. Okay, so this triple can hold the address of double, and double can hold the address of single, like that. Okay, but this type of things are not possible in reference. Okay, there is only one level of indirection in reference, but in pointer there are n number of indirections. You can have multiple pointers to hold the address of multiple pointers. Okay, so one level of indirection means you can refer r1 is equal to r. Okay, this is possible. There is no problem. This r is referring I, and this I is a normal variable. Now you can use this r to refer this I and initialize this to some another variable, and this is also a reference variable. Okay, so there is no problem in this case. So if you'll print r and if you'll print r1, both are same. Okay, let's check that. See, 10 and 10. Okay, so these are the differences of reference and pointers. So let's quickly recap all these things. First difference is memory address. You cannot have different memory addresses for different references. Okay, because they all point to one single variable, but that's not the case with pointers. Pointers have its own memory address. Second is reassignment is not possible with references. Once you created a reference, this r is pointing to I. Now you cannot make this r to point something else. Okay, so that's the second point. Third point is null value cannot be initialized to references. Okay, you cannot initialize null here like this. Okay, but pointers allow null initialization. Fourth is arithmetic operations are not possible on references until unless you use the address operator. Okay, and indirections is also not given to the references. It is only possible with the pointers. Okay, that's what we saw here. And if you're interested to know when you should use pointer and when you should reference, please watch my next video, because this video is getting a little bigger and it is really not a good idea to dump everything in one single video. And if you want to watch that video, link is given in the description field. Okay, so I'll see you in the next video.
And this question is, what is structural padding and packing in C and C++? Actually, this is going to be a really very interesting topic, okay? Because I have created lots of documents here just to make you a little more comfortable, okay? So, first of all, what is padding and packing, okay? So, padding is like you will be adding some extra bit to some size, and packing is like you don't want to do the padding, so you will be doing packing, okay? Instead of adding extra bit, you won't add any extra bit to the size of your class or structure and all that, okay? So first of all, just answer me, what would be the size of this base? Let's suppose you have created this base. Just forget about all the functions and all. Just this is your base class. And let's suppose you have these 4 data members like character, character, integer, character. So 1 byte, 1 byte, 4 byte and 1 byte. So total 7 bytes are there. So if you will print this size of base, it should print 7, right? So let's go and check that. So if you will compile this code and run this code, oh my god, what it is printing? It is printing 12, okay? Whether it should print 7, but it is printing 12. And let's suppose I'm just copying and pasting this from here to here, and you will just recompile this again and you will run this. So this time it is giving you 8. So why it is changing like this? Like why your base size is changing? This time also it didn't give you the correct output, but it is taking a little less size. So what is this all about? Why your base is not 7 as you expected? So just to assure you that it is actually 7, we have to write something like this. And we will compile it and we'll run it. We'll see 7. Okay. So for this moment, I will just comment this so that we can just understand why this is happening. Okay. So what you did, you just did the packing here. Okay. You tell to the compiler, don't do any padding here. So you just did packing. Okay. So why it is working like this? Just take an example here. Let's suppose this is your base. Okay. It is having one character, another character and integer. So it will be setting bytes like this. The memory layout will look like this. This is 1 byte. Okay. A is 1 byte. So it occupied 1 byte. So the 0th position is occupied. B is also 1 byte, so it occupied another place. After that, 2 empty space is left, and after that it is assigning this P. Oh my god, I should have written this I here. So okay, so this I is nothing but integer, so it will take obviously 4 bytes, so that's why it is occupying 4 bytes here. But why it is having these 2 extra bytes empty here? Why it is working like that? And if you will see second case here, let's suppose you are having one character here and integer I here and then character B here, then what you will do? What this compiler will do? Compiler will assign first byte here. After that it will keep 4 empty bytes and then after that it will assign this I. Oh my god. So instead of changing this, I will just simply change this. Okay, this P. So as you can see, this P is occupying 4 bytes as it is integer, and after that B is coming. Okay, and again this 3 byte is empty. So if you will print the size of this base, it will tell you 0 to 11, 12 bytes. Okay, so this is how it works. But why it is working like this? Actually, the point is, when you run your program, it gets divided into pages and it is stored in your hard disks. And when you are double clicking something like you're running your VLC player, you're running your any browser or something, it will load into the RAM. So when it is getting loaded into the RAM, it is called segments. Okay, so I will show you one process diagram here. I have kept it ready for you. So let's suppose you double click. So you created a process. So that process will first come into the waiting queue. After that it will go into the running queue. So it is running here. Okay. And when it is requiring any IO operation, it will get blocked here. After that, when that IO operation is triggered or that device is ready, you will get one interrupt and you will again start waiting and you will again go to the running state. So this is how this operating system actually works. Okay, there are lots of things, but this is the actual thing. Okay, and let's suppose your processor is of 32-bit. So have you ever imagined that why it is called 32-bit and 64-bit? It's just because 32-bit processor means it can process 32 bits altogether at once, at one clock cycle. Like if you are giving one clock to the system, it can process 32 bits. And that another 64-bit means it can process 64-bit altogether if you will give one clock to that. Okay, so that is the reason. So in that case, when it is going to process 4 bytes, the computer researchers found that if you will keep your data like this, like 7, if you will keep your data like this, it might be looking something like, I will just copy and paste this situation here, and I will just simply remove this too. Okay, so in our thinking, it should look like this. But what your processor read? It read 4 bytes altogether. So processor will take first 4 bytes, okay, and it will read. So when this 4 byte has gone to the processor, it can read A and B without any problem. But let's suppose you want to read I, okay, which is this I, these 4. So in that situation, processor has to read this portion to get these 2 bytes of I, and after that processor has to read this 2. Okay, so that's why there are 2 read, okay, to the memory. So that's why it is a big penalty. So just to remove that penalty, we pad the extra bytes. Okay, so now let's see if this is the situation here and you want to access A or B or something. These first 4 bytes will go to the processor. Processor will read A and B without any problem. Just need a shifting here. Okay, and if suppose processor want to read I, processor will read another segment or page. Okay, so we divide whole memory into segments. Okay, so if it is stored at hard disk, it is called pages. If it is brought to the memory, it is called segments. Okay, so that is the only difference. And we do paging concept, and that paging help you to map pages to the segment. Okay, because your processor always generate logical address, not the physical address. Okay, it doesn't know about your RAM. It asks the logical address. Okay, so this is how it works. I mean, if you are not good in operating system, you might find it little difficult to understand. But in just simple way, you need to understand one thing. Processor will read 4 byte. Okay, if it is 32-bit, just remember that if it is 32-bit, it will read 4 byte. Okay, and you cannot tell like why it is not reading from here. Okay, no, this when the pages were created, it was created like this. First, these 4 byte went to one page. Okay, or one word size, that is also a proper terminology, and another 4 bytes, let's suppose here it will do the padding actually. Okay, then another will go to another page. Okay, or another word. I think I should use the word here. So this is one word and this one is another word. So you cannot say why it is not reading from here. No, processor doesn't have that advantage, but nowadays processor does have that advantage. Nowadays scientists and processor creators are telling that there is no penalty even if you don't pad any extra byte, but I'm not that sure about that, but I have read that article somewhere, so I'm just telling you that. Okay, just keep that in your mind. And there is a rule. Let's understand the rule. Okay, so how data gets memory slot, this is the rule for that. 1 byte can go and can be stored at multiple of 1 memory slot. So what do I mean by that? So let's suppose there is a memory slot. It starts from 0 and 1 and 2 and 3 4 5 6 7 8 9 and 10. Okay, so this 1 can go anywhere because 1 is the multiple of all. So 1 can go anywhere, but 2 can go at multiple of 2 only. So it can go at 0th location, at 4th location, at 6th location. 2 cannot go at first location. Okay, so that is the memory mapping work. Okay, if the size of your data type is 2 byte, it will never go to first byte position. That is how the memory optimization and all these algorithm and all those stuff work internally. So if it is 4 byte, it will go multiple of 4, like it can go to 0th location. So if it is going at 0th location, that means it is occupying from 0 to 3. So that's why it is requiring multiple of 4. Okay, from 0 to 3. And then if it is already occupied like from 0 to 3, suppose this 1 was already occupied, then it will never take 1 2 3. No, it will search for 4. So 4, but still it should get consecutive 4 empty space to get into this slot. Okay, so this is how things work. And in case of 8 byte, it will always check consecutive 8 empty bytes, but that should be multiple of 8. Like it should be starting from 0th position or from the 8th position. It will never go to either of 1 to 7. Okay, so this is how things work. So am I left with something? One word is 4 byte in 32-bit processor and one word is 8 byte in 64-bit processor. So that I already explained you. Word is nothing but pages, and I can explain you or just leave it. No need to go into that deep because otherwise I will become operating system teacher here. For now you just understand this much only, that padding gives boost to your program. Like it will get read by 4 byte if it is 32-bit processor. Okay, so first 4 byte will go like this. And yeah, one more thing I wanted to tell you. If it is like this, then 0th byte will get A here, first byte will get B here, second byte will get C here, and another time that third byte will get padding. Okay, so here you will get one padding, and after that this integer is going to get 4 byte. So it will be like total 8 byte. So that we can just simply check here by compiling. Okay, we will compile this. Oh, what am I missing in here? Define constant. What is this? Am I doing something? Okay, I will just remove this. We will go up. I will compile. Check. Yeah, 8. Why it is 8? I already told. This is first byte, second byte, third byte, fourth byte is padded, and now this is starting from the the fourth byte because the indexing starts from the 0. Okay, so it will look something like this. A is at 0 position, B is at first position, is at second position, and there is one padding, and then third is coming, third is padded. Okay, and then I is at 4 5 6 and 7. Okay, so I. So this is like this. But let's suppose if you will remove these two like B and C, then how it will be? It is not going to look like this. Okay, it is not going to look like this. It is going to look like this. Why? Because it pads multiple of the maximum available data type here. Okay, so I will just give you the example here. I will just simply remove this. And what do you think? What it should be? Like before it was having B and C here, like B and C. So if you will remove this B and C from this place, then it won't be looking like this. Why? Because I will just simply compile. Oh my god, I always mess up things. And then we'll just simply compile. Check. 8 again. Even if you remove B and C, it is not changing. It is again, it was 8 and it is again 8. Okay. So what is this? Why it is not changing? The reason is that only. What I told you there. Like this is a 4-byte data type. This is a 1-byte data type. So this 1-byte data type already occupied the 0th place. Now this 4-byte data type will look for 4 consecutive byte. So it will start looking from here, but it will not get. So as it is 4-byte data type, it will get stored multiple at 4. Okay. So that's why it is starting from 4 here. That's why it is having this size 8. So let's suppose if you are using some sort or something like SHORT sort. In that case, what should happen? Like sort is of 2 byte, okay? So in that situation, it would be like this. Only 4. Because sort is 2. So what did I said? If it is 2 here, then it will look for the multiple of 2. So what do you mean by multiple of 2 here? Multiple of 2 is 0 position. 0 is already occupied by A. 1 is not the multiple of 2. So this 2 is the multiple of 2 and 2 and 3 was empty. So it will occupy that size. So the size would be these 4 bytes. So that we can see here. I'll just simply compile. No, before that, I always forget this one. I'll just simply compile fast 4. Okay. Now I think I made my point, guys. Oh, is there anything left? I don't remember. Yeah. And even if you are interested to remove this one, okay, remove this extra padding, you are just going to use this pragma pack here. Okay, compile and check. See, now you are having 3. So 1 and 3. You are saving so much of memory, but it might give you a big penalty. Okay, but researchers claim that now there is no need of doing that extra padding, but still you should know this concept to answer to your interviewer. That's why I'm explaining this, okay? So I think I'm done here. Thanks for watching. Bye-bye.
And this is about use of friend function and classes in C++. So lots of people get confused like where to use friend function, and let me tell you, this is my opinion and I found some of the statement on internet, especially on Stack Overflow, and people are talking about this with their own experience. So there is no straightforward answer for this question, but you can convince someone by this. Okay, so let's start. So first of all, we'll see a friend function. We'll talk about the classes later. So let me write a class here. Here you're having base class, and let's suppose you're having one integer x, and we got this constructor, and let's assign some value here. So x. Okay, so this is what it is. You have this public here, and you're creating b with value 10, and here is this function. Let's create that function void set, or let's keep this as function. Okay, and what you're doing is you're getting this base reference obj, and inside obj you're having this x is equal to 20. Okay, so let me do this like cout obj.x and deal first, and cout obj.x here. So this is before and this is after changing. So we all know that it is not allowed for this function to directly access .x of this base, because this .x is a private member inside class and you cannot use this x outside this class. Okay, so let's make this function as a friend.
function, and you're done. Base ref. Okay, so if you will compile this code, everything is fine. The only thing is we have not called this function yet, so nothing is printed. So let's give this b here and rerun this again. See, it is 10 and 20. So this is what this friend function does. And some of the people get confused by saying that this is breaking the encapsulation rule in C++, but it is not breaking, because this function is not telling that I am the friend of this class. Actually, this class is telling that this guy is my friend. So you are the owner of your class and you are defining that some function is your friend. So there is no break of encapsulation, right? It's you who is telling, not the other way. So this was about how friend function work. Okay, so let's look at where to use this feature of C++ and where comes this handy. So let's suppose there is a class called employee, and this is a class. It has ename, which is employee name, age, and all that stuff. Okay, so this is your employee class. Now there is another class, let's call that class an admin. So here is the thing, you are an employee, you are allowed to change the details about you, whatever is there inside this class. No one else can do this, because if you are an employee, you will be having login ID and password. Like that, you will log in and you will change your stuff. Okay, like details in your company, correct? But what if admin wants to change something in your detail? That admin should have the rights to change these, right? And until unless that admin got that username and password, admin cannot change this. But as this is admin should have all the rights, right? So what we generally do, we make this admin class, or if it is function, okay, we make this as a friend. Okay, so by saying that this admin is my friend, now admin class has all the rights what this employee class has. Okay, there are a few other stuff, like if this is the hierarchy of inheritance, like A, B, C and D. Let's suppose you are here, this C class, these are classes, okay, A, B, C, D. This C class is making some function. Let's suppose there is some function fun, and this C class is making this one as the friend. Then this function has the rights only to access the stuff, the private, protected and public member of C class only. This function cannot access what is coming from B and A. Let's suppose this B is having some data member X, or let's call that data member a small b, and this one is having a small a, integer a, integer b. This function will not have access to b and a. If you want to remember this, there is very good statement that if someone is your friend, you are here, and someone is your friend, then that friend will be your friend, not your daddy's friend or your mother's friend. I know this relation is not daddy and mother relation, but still, if you want to remember that, this is very good way to remember. Your friend is only your friend. So your friend can come to your home and can access whatever is there inside your room, not your daddy's room. Okay, he can use whatever belongs to you. Okay, not anyone else in your whole relationship. Okay, so that's the way to remember this. So yeah, we were talking about this friend admin thing, right? So this is one of the way you can use a friend class or friend function. Okay, if you are defining some class as your friend, then that whole class has the rights to access your private and protected and public data. But if you are creating some friend function, that only that function, particularly that function, is having that right. Okay, that's the only difference between function and class making as friend. Okay, and the guy who created C++, Bezane Strostrup, if I pronounce correctly, he said in one of his blog or website that friend keyword is mainly used for giving the rights explicitly. And I have seen so many people talking about that they are using this friend thing in testing. Let's suppose there is some class. Let me just remove everything. So let's suppose there is some class here. Let's call it base, and there are a whole bunch of data member, data functions, and everything is there. This full class is ready now, and you want to test this class. Okay, so here is your int main function. You started your program, and let's suppose your program is ending here somewhere, and this is maybe calling here and there, so many places. And let's suppose here somewhere you want to check the status of this base class object, and you don't have getters and setters for all the variables, data members of this class. Let's suppose this is integer x, and you don't have the function which will give you the x, like get x. This function is not available inside this base class. Then how you will test this class? So this is the way. What you will do, you will make some function here. Let's call that function. You will grant this function by saying that, okay, friend function. Okay, so this function will become the friend of this class. Now inside this function you can happily use obj.x, and you can print this, do whatever you want to do. So can you see that you are not messing with this class? And by messing means you are not including extra code what it doesn't require inside this base. Okay, that extra thing you are doing outside your class. Few people say that for testing purpose they use this friend keyword. Okay, so this is another good way to use this. And for testing purpose, let's suppose you are having so many test cases, like suppose you are having so many functionalities here, having so many data members, and depending on situation you might be having some values, and if the situation changes you might be having some different values. So all those testing code can go here, and you will make this one as a class, and you will write different functions, and all those functions will have rights to get the private and protected and public member of this class and do whatever they want to do. So if the test cases are bigger, you will go for friend class. Got it? And another use can be, let's suppose you are having 10 to 15 or 20, or let's suppose 20 classes, A, B, C, D, E, and all that, and you want one particular function or one particular intermediator which will be the intermediator among all these classes. So it will become very simple if you will make this as a friend inside all these classes. Okay, then this will become a super function which can access all the data members inside these classes. So these situations can arise in programming. There is ocean in programming world. You cannot imagine what could be the requirement. So there is no hard and fast rule that you have to use friend function or friend classes in such a way, but these are the scenarios. Okay, I hope you like the video. Don't forget to hit the like button if you like the video, and if you haven't subscribed it, go for it. It would help me a lot. Thanks for watching. I'll see you in the next video. Bye bye.
And in this question we'll be learning about how to call same base class function from derived class object. Okay, so I want to create the object of this class but call this function, not this function. Okay, let's see what do I want.
and from D we want to call that function, and I want to call base function, not the derived function. So if you compile this, you will see that it is compiling and running, and the output is derived, but I want base. How would you do that? The one and very famous way is to use scope resolution operator. Okay, so here you are calling function on derived object D. So this is obviously going to call this one, okay, because this is static binding, and compile time it will bind to this function only. Okay, it is not going to bind to this function, and this is also a static binding. Remember, dynamic binding happens only when we use virtual keyword. Okay, so this is also a static binding, and this time we are explicitly telling that the function should be from base. Okay, so that's how this will call your base function. See, first it is calling derived and then it is calling base. Okay, so this was the very accurate way of doing this. But what are all those other ways of doing the same thing? You can typecast this derived class into base class and you can call that function. Okay, like this: base b is equal to static cast base, and here is your derived. Okay, if you would compile b dot fun, this is going to call base function C. Okay, not the derived function. And this is also a static binding. It binds at compile time. B is of type base function, base, that's why it is calling base function. Okay, but doing this will make the object slicing, so the derived part from D would get sliced off and the only B part would remain inside this. Okay, so if you want to typecast this back into the derived class, you won't be able to do that. Okay, so in order to achieve that, you have to use the pointer. Okay, so if you are typecasting D, this one, into base pointer, then you can do that. I mean, the upcast is allowed. Okay, so if you would do something like this, now compile. See, it is doing the same thing. Now you can typecast this base into derived again. Okay, I mean to say this derived D1 is equal to static cast derived pointer B. Okay, and D1 would hold exact this one. See, so this is possible. I mean, this downcast is possible after this upcast because we are doing this with pointers. Okay, if you are not doing with this, I mean the converting into the pointer, if you are converting into the object itself, then the object slicing will come into the picture and you won't be able to cast this B back to the derived. Okay, let's look at the next question now.
And the question is how to print something. Let's suppose you want to print CPP nuts, but without using semicolon in your program. Okay, so if you have not understood my question, I want you to use this printf and print something like CPP nuts like this, but I don't want you to use this semicolon. Okay, after this, how would you do that? If I will run this code, it will say that expected semicolon. So think about it and think hard. I think you have got your answers, so it might be a little shocking, but you can print it like this. Okay, so what you did, you included that printf inside if. Okay, and this is the starting in the end curly braces. So if you'll run this, your answer is CPP nuts, and it is working. Not only if, you can put inside while as well, like while printf and CPP nuts. Okay, and here is the opening and closing bracket. But the problem with the while is printf returns how many characters it printed on the console. So it will be printing 7 characters. So printf will return 7 inside while. Okay, so 7 will come here, and that is not a 0, then
while will run again, and this is empty while, so nothing will come here. It will keep on running. So if you want to see that, let's run this program. See, it is running in infinite loop. Okay, so to solve that, we will put one negation here. Okay, so if you will keep this one, whatever the non-zero value will come, if you are keeping this operator, it will become a zero value. Okay, means everything except 0 is true in our programming, even if it is minus value or whatever the value is. But if it is 0, then it is false. So this will make it 0 or false. So if you will run this time, it will print CPP nuts, CPP nuts. Okay, so this is the way of printing anything without using semicolon. I know this is really very small question, but knowing these tricks will include so much of knowledge about how things work. Okay, so you might be able to mold this thing and use somewhere else. Okay, so thanks for watching, and let's look at the next question.
Today's topic is a to I function. So this is a function. Okay, this a means ASCII, 2 means we will be converting to an integer. Okay, so we will be converting ASCII to the integer, and this is a function already given in the C and C++ language. So let's see first the use of this function, then we'll go and create our own function of this type, because lots of interviewers ask you to implement a to I function. Okay, so the use of this function is it will convert your string into an integer, but that string should contain the numbers like 1, 5, 9, 0, 8. Okay, like this. So this is a string. If you will convert this into integer, it will still look like 15908, but this is integer part, so you can now apply any addition, minus, multiplication and all those arithmetic operation on this. Okay, because this is integer. Okay, you cannot do all those things here because this is a character pointer. Okay, so we want this to this. Generally we get this because when we are dealing with websites and web development cases, if you are passing something from website to your C code, everything generally comes in a string format. Okay, so you have to convert it into the integer format and you have to use that. That's where we use this a to I. That's what I can recall where I use this. Okay, so this was the use of ASCII to integer function. Let's look at the code for this. So this is your code now. As you can see, we have this particular string, and yeah, I forgot to mention that string could be a minus also. Okay, so this is minus 1 2 3 4, and this is a character array. We will pass that character array to my a to I function. Okay, so this is the code for converting your character pointer into the integer. Okay, so these are some variables we'll be using. So ultimately this is our result, this is our sign bit, and this is the index what we are currently pointing to that character array. Okay, so these are just simply initialization. Now let's come to this point. If your input is minus, then str's 0 position will be holding this character. Okay, so 0th location will be having this particular character. Okay, so yes, it is true. So we'll do sign is equal to -1 and we'll increment our pointer of I. So now we'll be pointing to the next location. Now I is 1 and we will start from 1 until unless we get the null. Okay, and this is a very basic technique we use to create your integer from your character pointer. Okay, the only thing you have to take care of is this one. Okay, you are taking the character and minus character 0. This is the key to convert your string into integer. Okay, so let me explain this little further. If your string is like 1 2 3 and at a time you will be picking 1, so this is like this, 1 minus 0. Okay, and this will produce 1, and this is an integer 1. Okay, how this is happening? Actually you are not doing this character minus. Actually this 0 is 48 in the ASCII and this 1 is 49. Okay, so 49 minus 48 will result into 1. Okay, so if your 0 is a character this 1, 2, 3, 4, 5. Okay, so this is an ASCII value, this is the character. So if you will minus 0 with any of the character, you will get that difference only. That's why we do this. Okay, so this is where the character will be, and you will do the minus of 0. But don't forget, this 0 is not simple 0, this is a character 0. Okay, so if your I is 1 and your string which is passed is this one, like minus 1, 2, 3 and 4, then your I is pointing to this location, and initially your result is 0. 0 into 10 plus stri, which is 1 minus 0 will be 0. So your result will be 1. Okay, in first case. Then we will increment our I, we'll go back inside this. Now we are pointing at 2, so it is going to be 1 into 10 plus 2. Okay, 1 is because this res is updated, right? So new value will be this one, res is equal to this one, so it is going to be 12. Okay, we do this trick so that your number will get incremented, okay, by digits. You are just including one more digit into that. Initially it was 1, okay, then it has to be 12, right? 12 is nothing but 1 into 10 plus 2. Now if it should be 1, 2, 3, then currently if it is 12, you have to multiply it by 10 to make 1, 2, 0, which is 3 digit. Now you add 3, so it will make 1, 2, 3. Okay, so this is kind of a trick we use to increase our integer by digits. Okay, and just simply this will add the number inside that and we will get our integer. Okay, and lastly we are multiplying the sign bit. I mean the sign, if it is minus 1, it will become minus, I mean the result will become minus. If we didn't went inside this function, let's suppose this minus is not there, then we will not go inside this function and just simply hold 1 here, and 1 into something will result into the same number and we'll return that number. Okay, so let's quickly see the working of this one. So if this is the code, first let's compile the code. See, you have got minus 1, 2, 3, 4, and see I'm printing value here. Okay, and let's suppose you are having some another string like this. We are getting into value 1 and 2 and we are just printing the addition. So it will be 5555 but minus 555. Okay, and if we are keeping this one as positive and this one as negative, the result would be 3087. Okay, that's it. So I think you got the point here. The main thing was just to remember, if you want to convert any character, like this is a character, right? If this is a character 1, you want to convert it into integer 1, just do this minus with 0. Okay, and now if you will store it in some integer I, that I will hold the integer part of 1. Okay, because we have this ASCII value like this, and we do the minus of this one with this one, we will get the difference as 1. Okay, so that's the trick and nothing more to understand this. This function and all can be implemented in any ways. We have not included any check here, like if your string what you are passing is holding some non-integer value. Maybe if your string is holding like this is like 1 2 k 3 c. Okay, so if you will try to convert this one into string, that string will not be perfect because we are having k and c here. Okay, this is 3, so we have to check that also, but the main point was how to convert that, and this is the way of doing that. Okay, so thanks for watching, and in this question we will be learning how to stop someone from taking the address of your object. Yes, you heard that correctly. You are stopping someone from taking the address of your object. Okay, so if you have some class like this and you created the object of that like base b, and you just simply wanted to print the address of b, then you can print that. Okay, let's compile this. See, you got the address of your object. Okay, you can initialize this object address
inside some pointer also, like base pointer bp is equal to address of b. Okay, and you can print that also, both will be equal. Okay, but that's not the point. The point is how to stop someone from taking the address of your object. Okay, so first of all, you should know that the address operator is internally overloaded in your class. Okay, so even though you don't overload this address operator inside your class, C++ compilation include that inside. Okay, so whenever you create any class, the address operator gets overloaded automatically. Okay, so now we will use the same technique to achieve our goal. Okay, and first technique would be overload the address operator and keep it private. Okay, oh, not this one, we should write it like this, delete this operator. Okay, that was a typo. Now, as I said, we have two options, overload the address operator and keep it private. So let's do that. So yes, this is a base pointer operator address. We need just return this. Okay, and this is what it does. So let's compile this and check the correctness. Yes, it is working. So whenever now we are using this address operator here and here, we are ultimately calling this function. Okay, so before this function was hidden inside our class, we were not giving, then also it was including, but now in this case we are giving it. Okay, so obviously this will use this only. So let's print some message so that we can see it is really calling this function. Okay, so let's compile this. See, bingo and this address, and bingo and this address. Okay, so first you got here, then you will come and print the bingo and you will get this address. Okay, so as we can see, it is coming here. Now as I told that we will be keeping it as a private, so let's do that. So it is really very obvious that if you make it private like this, then you won't be able to call it from your main function, because main is the outside from your base class. Okay, and we cannot call private member functions from outside your class. Okay, so if you will compile this, it won't compile. See, there are lots of errors. So it is telling that base pointer operator, this is private in this context. Okay, so this was the one way to stop someone taking the address of your object. Another way is you just simply delete this operator. What do I mean by that? So let's remove this private thing here, and no need to give the this part also. Delete means this. Okay, this statement tells that this is a new, it is from C++ 11. So if you will delete some function, it tells to the compiler that don't create this function. Okay, and if it is going to create internally, it won't do that. Okay, as I told you in the beginning that your class already has an operator overloaded inside that, even though you don't give it. But now if you are writing it like this, your compiler is not gonna create that function internally. Okay, so let's compile this as well. Now it will tell that use of deleted function. Okay, the same thing is happening. Now you cannot compile your code so that user won't be able to get the address of your object. Okay, so if you are not getting the address of your object, this code will compile. Okay, so just remove this one, and this one, and let's compile this code. See, it has compiled. So wherever this address is coming, that line will not compile. Okay, so that's how we stop someone from taking the address of your object. If you are asking for the applicability of this, then I would say it depends upon your application, like what you require. Maybe you require this because you don't want someone taking the address of your object so that they can change it using the address. Okay, no, you don't want that, so that's where you will use this. Okay, so thanks for watching.
Why to use operator overloading? So this video is not about how to use operator overloading. This video is about when you will use operator overloading, because this facility is given, so we should be knowing when to use that. And the answer for that is use when it makes sense. Okay, so there are lots of operators like plus, minus, and all that. So we will use all those operators whenever it makes sense. And make sense means you will not add rocket plus table. Okay, if these two objects are there, you won't add these two objects. Okay, not even rocket plus rocket, because it doesn't make any sense. Okay, like table plus table doesn't make any sense. Okay, like human plus human doesn't make any sense. But if there is a number plus number makes sense. Okay, number minus number makes sense. Okay, so we will use operator overloading when there is some number involved, and not in number case only. We use operator overloading in string also, like if there is a string like CPP nuts and there is another string like Rupesh, then in that case you want to add this one with this one, then also we use this add operation. Okay, so the point to notice is you won't use operator overloading for something which doesn't make sense. Okay, although you can do that, but doing that won't be a good idea, because the reader of your code won't be able to understand why actually you are doing that until unless your function is exposed to the user. Okay, so that is not a good idea. It should be a super intuitive. Okay, so we'll take some examples here and we'll try to demonstrate the use of that. So as I said, we can have some number, like I will say a point. Okay, it could be a point in two-dimensional space, then we can use x and y, and we can have a simple constructor and a parameterized constructor integer y. Okay, so this we will use for initializing the values, and these should be public. Now here comes the operator overloading part. Now what you would like to do is like point p1, and you are giving some value like 2,3, and p2 is like 4,5, and you want to add p1 and p2 and assign into something like p3. Okay, p1 plus p2. Okay, so it's quite obvious that you might be willing to do this because these are the two-dimensional coordinates x and y, and you want to reach somewhere by adding these two points. Okay, so let's see how to give the overloaded operator in case if you don't know. Then the syntax is the addition of p1 and p2 should be like point only, right? Because this p1 and p2 both are of point type, so in that case their return should be also of same type, so we'll have a return type point. Now there is a rule: if you are overloading, then you have to use something called operator. This is a keyword we use, and after that we use what we are overloading. So we are overloading plus, and then you will have these arguments. So we know if we overload any operator, this overloaded function will be called on that particular object. So this p1 will come internally inside this, and p2 will be passed. Okay, so let's do that. Constant point ref p2. Okay, and we can just simply return the addition of these two. Now it's up to us how we return that. You can create a simple point p, and let me do this, otherwise it could be a problem for so many people. They might ask me that why I didn't include this. Okay, so if you are doing it like this, we can simply initialize p dot x is equal to x plus p2 dot x, and the same for p dot y is equal to y plus p2 dot y. Okay, and we can return this p. Okay, so that would come here. Okay, so let's compile and check the correctness of this function. It has compiled, so there is no problem in this code. Now let's verify the working of this. We can overload cout operator, but that I wanted to include in some another video because that requires little more explanation about how to overload and why we use cout overloading and why it is taken as friend function inside your class. So that is a different talk. So for better use, we can just simply create a print function. There we'll print
x and y, x here and y. And if you want to print p3, which will tell you that okay, you have got it correctly, it will show you that. Okay, so 2 will be added with 4, so it is 6, and 3 will be added with 5, so it is 8. So that's a working code. Okay, so this was not the point actually. The point was why to use operator overloading, and the answer is whenever it makes sense. Okay, we have seen operator overloading in string cases also, like string str is equal to Rupesh Yadav. Okay, and maybe in future you want to add something to this string, then you would simply do like this: str plus cpp nuts. Okay, so if you will print this str, then you will get the conjunction of both. See, Rupesh Yadav, cpp nuts. I have not given the space here. Okay, let's compile again and see. Okay, so here you are adding two different string, so it doesn't force you to use only on the numbers. That's why I'm telling, use when it makes sense. So it makes sense in adding string also. It might be making sense in some other case also, I don't know, but this is the small and sweet answer. Okay, thanks for watching.
Function pointer. So we'll try to answer these questions here, like what is function pointer and how to create them, and calling a function pointer using a function pointer itself. And last, what is the actual use of function pointer, where we should use function pointer, not anything else. Okay, so stay with me and let's start it. So first of all, what is function pointer? So I have these questions and answer here. So as we all know that normal pointers variables store the address of another variable. Okay, so if you are writing something like this, integer I and integer pointer p, so this pointer p will hold the address of I. Okay, so we all know that very well. Okay, now what is function pointer? If it is function pointer, it will be storing the address of another function. Okay, so first you remember that. Now the question is how to create them. So we'll take the example of this normal pointer itself. So let's suppose you have some function which will add two numbers and return the addition. Now you're going to create a function pointer which will store the address of this add. Okay, so how do you do that? So let's take an example of this one here. You wanted to store the address of I, so you created integer pointer. See, you didn't create a character pointer and stored the address of I. No, you did this. Okay, you created integer pointer and stored the integer data type's address inside that. Okay, so if you want to store this type of address, then you have to create this type of pointer to hold this address. And what do I mean by that is the function pointer what you are going to create should return integer and should take two integers like this as a parameter. And it is really very simple to create function pointers. Why? Because what you did in case of normal pointer here, you just created a variable and at front of the name you just put this star mark. Okay, so we'll do the same with function. Let's suppose you have this function name and it is returning two integers, and you will write this pointer at front of this function name. But hold on guys, this is not done. If you will see something like this, what would you think? There is a function. That function is taking two arguments as integer and returning integer pointer. It is looking like you're returning integer pointer. This is not looking like a function pointer. So this star or asterisk should be with this name. So how to associate this? This is the way. And you are done. Now it is function pointer. And you can happily assign this add here. Okay. So let's see whether this code is really a working code. So this is your program. This is the add function and we are creating a function pointer here. So let's compile this. So this is GCC, program name is demo. We compile it. There is no issue in this program. Okay. So what we have learned is how to create a function pointer here. Okay. So what it is doing actually, it is holding the address of this add function. And there are two ways to do this. I just literally forgot to mention that, but I should mention that as well. There is this way of assigning the address of A, and this is another way. Okay, so this is most perfect way because this will work even with the old compilers. This is not going to work with old compilers. Okay, so better you should always use this one if you want to migrate from new compiler to old compiler. Now, as this add is here, now you can use this function to call this function. That's the only thing what this function pointer is meant for. Okay, you will be calling some function with some another name. Okay, so you're calling this add function with this function, and let's see how. So if you want to call some function here, you just simply pass these two values. You will get some value like C here, and we can just simply go ahead and print that. So let's compile this code. There's no problem. If you run this, the answer is 3. So 1, 2, and 3. So you notice that your function pointer thing is working. But wait a second. This is a new way to call function. And this is the traditional way. Okay. So I told you how to assign that by using address operator, and how to call function. There was that simple way, and this is the traditional way. So let's check this out, that this traditional is working. And yeah, see, it is working. Okay, now we know how to create function pointer, and we know how to call them. Okay, and as I told you that your function pointer should be of type exactly what you are going to assign in that. Okay, so this add is of type returning integer and taking 2 parameters. That's why your function pointer is also returning integer and taking 2 integer parameters. Okay, so if you will make some change here, let's suppose you are adding one extra integer, in that case, if you will compile, there will be an error, too few arguments to function fun. Okay, and if you will add another argument like 1, 2, 3, and you will go and compile, so here you got the warning because wait a second, and the result is 3. So this is what I wanted to show you, that if your pointer is of not the same type what you are assigning into that, is a problem here. Okay, see the warning here. So you should avoid using this, because see, this third value is avoided here. Okay, only 1 and 2 are passed, and you are returning is the addition of 1 and 2 here. Okay, so far we have learned about function pointers and how to create them. Okay, now there is another question, and that question is this calling a function using a function pointer. We already saw this, so we will skip this question. Now there is this another question, how to pass a function pointer as an argument to another function. So let's create another function here. So let's try to understand what is happening here. You have one function, function1, and you're passing this add, which means you're passing the address of this add function to this function, and you're catching that address like this. Okay, so this is how you write in function parameter when you are getting some function's address. Okay, so let's run this. If you will compile this, okay, I forgot to have this C here. Okay, so let's compile again. There is no issue. If you will run this, answer is still 3. Okay, so this function we are calling add function here with some function name, and that some function is getting created like this. Now we will see another question here, and that question is how to return a function pointer. And this is really very interesting question. It was so easy, right? What function type you want to return? These both functions prototype is same. I mean, both are taking 2 integers and returning 1 integer. So you created a type of the same prototype here. Now let's look at the another one. That another one is little tricky. Let's suppose you don't want to use this type def and all, then how you will deal with this? So this is your function which will return a function pointer of this type. Okay, so let's do that. And this type is returning integer and taking 2 integers. So first of all, you will enclose this function with one round bracket here like this. So this has become the name parameter, integer and integer, and the return type was integer. And one more thing, this pointer. And you're set. Now there is this function fun which returns a function pointer of type taking 2 integer as a parameter and returning 1 integer. Okay, so this is how this whole thing will work. So let's compare whether it is working or not. So it is working and the answer is still 3. I know this is little tricky and hard as compared to this type def thing, and that type def was more readable than this. Okay, so if I will remove all that, see, this function is a function which will return this math function type. Okay, this is a type, not a function. Okay, don't get confused. You always write type here like integer and character. Okay, so if I'm writing this math function, that means it is a type, and we are defining a type like this using type def. And the syntax to define a function pointer as a type is this. Okay, I know this is a little bit hard to understand, but once you will practice 2-3 times, like pass some function and return some function and try to do all those things what I taught you here, it will be a little easier for you to remember all these things. Okay, so we have seen how to return a function pointer. Now there is a question which says how to use arrays of function pointers. So now I will create arrays of functions. So see, this is really very easy, right? That you are creating an array of 2 size, and the type of that array is math function, which is nothing but a function pointer, return integer, and take 2 integer as a parameter. Okay, that's why we are assigning these 2 functions of this type into the array. Okay, and this is the syntax of calling that. And yeah, this is new syntax actually. You should call it like this, and this pointer and this pointer. Okay, so let's compile this as well. There's no problem, and the same answer. Okay, now this was a very neat and clean way to create an array of function pointers, because you have this type created already using type def. What if you are not using this type def and you want to create an array which stores these 2 functions of type this? In that case, you will again do the same thing. You will wrap this, put this pointer here. Now you do integer and integer comma integer. What we did before, I told you to wrap whatever that function was when we were learning returning a function from another function. I mean, returning a function pointer from some another function. That time I told, if you're not using that type def, then you will be wrapping up your function and write the type like this. So here you wrapped up your array with this pointer sign and return type like this. Okay, and now we're good to go. Let's compile this. This is compiled and running. It is working. Okay, so now you're not using this type def thing and all that, but I would recommend using that because that gives a code readability. This is so much confusing, right? So we have seen how to create an array of function pointers. Okay, like this. Now let's look at the next question here, and that question is where to use function pointers. This is really very important question. So I have a program for that, and the best use I can say is you will pass your function's address, okay, to some another function, and there you will use this function, okay, or any function you want to use. So the best use is in C, we know there is something called qsort, which is quick sort. This is inbuilt function which will sort your array. So let's suppose you are having some array, you will pass that array inside this qsort, and this qsort will sort that array. And there are a few parameters you need to give, and lastly you have to give the address of your function which will compare the elements. Okay, so qsort need a function to compare two elements. Okay, so let's run this and find whether it is really working or not. So this is GCC demo, and now if you will run this, see 1 2 3 4 5. So you give this array in quicksort sorted out the elements inside that with the help of this compare function, and after that we are just simply printing the whole array. Okay, and as I told, this is making the ascending order. If you will make like this, like left hand side is less than right hand side, and then if you will return true, then this will become descending order. Let's compile this and check this again. See, first it is printing 5 4 3 2 1. Before it was 1 2 3 4 5. Okay, so we can clearly see that this is playing a major role here, but that is not the point. The point is qsort need one function as a parameter. Okay, this function is a user defined function, this compare function, because sometimes what happens, you are sorting some structure. This is integer value, so it's okay, but let's suppose you're sorting some structure or something, then in that case you will be passing two structure pointers. You will typecast that into the structure, and inside that structure there would be some field. On that basis you will be sorting that whole structure. Okay, I mean array of structures. So in that case this compare function becomes really handy. So that's the only reason this compare function is given to us. I mean, we are supposed to implement this function. The rest of the things are taken care by this qsort, but the compare thing is given to us. Okay, because our data could be anything. It could be class or anything. Okay, so to recap that, the best use is you will be passing your function according to your need. This is really very good example to understand this. Okay, so I think you got the video. If you like the video, don't forget to hit the like and subscribe button if you haven't subscribed yet. I'll see you in the next video.
Why returning reference is bad sometimes? Yes, it is bad sometimes, and this is the situation that if you are returning reference to a local variable, then it is a problem. See, this function is being called here, it is coming here, you are creating one integer variable which is local to this whole scope, I mean this function scope, and this I is going to get erased once this function will finish its call. Okay, so this is called here, you are just initializing one I, you are returning that I, but the reference, not the value. Okay, so that reference will come here and we are just printing that A here. So we'll see what is the output of this. Actually it is undefined, but we can still check the output, right? So let's check this. This is G++. There is a warning that you're returning a reference to a local, but that's okay, we can compile that. Segmentation fault. Okay, so it is obvious and we can expect this error. There is no surprise in this error, okay, because we are going to access something, this I, and this doesn't exist, so it's obviously a segmentation fault. And someone will say that if it is giving you a warning, then also why you are going to go ahead and run your code? No, sometimes people just don't look at the warning. Okay, and as it is undefined behavior, you might not get segmentation fault, you might get some garbage value. I can fairly expect that. Okay, where you can use this return reference is in classes. You might have seen those copy assignment operator, and lots of places we use this because it makes sense. But in this case it doesn't make any sense. You can return this I, but if you are taking it in some another way, like I from here, and let's suppose this I is already initialized with something, you are passing this I here, you are getting it with reference, integer reference I, you are changing that I with some very meaningful way, like I plus 15, this 15 you get after so much of calculation here, let's suppose like that. Okay, and after that you add that 15 to that I, and now you can return the reference of that I and you can initialize this one. We'll run this code, it will work. But lots of people might think that what is the need of making one reference of this one? That's up to you. Okay, I just gave the example here, but this is a fair case. You can just simply use this one. Okay, so this is a very small topic, but it's really important topic for freshers. So I'll see you in the next video. Thanks for watching. How do you determine that when you call some function like this, which one will execute first and which one will execute second? Okay, because so what happens, there is one dependency, like you are calling this function 2, so you are thinking I'm writing this build here, so this will execute first, and use here, so this will get execute second. Okay, or vice versa. If you are using, you are building here, then this will execute first and this will execute second. But let me tell you one thing, this is undefined behavior. It is totally independent to the compiler builders, that how they are building this thing. Like either they are using stack, like they'll push this one first, then this one first, then execute this one and then this one, or they can use this reverse stack, like they will push this one first, then this one first, then they will execute this one and then this one. Okay, so you don't need to be sure that first this one will be called, then this one will be called, or vice versa. Okay, because there is no order defined function parameter call evaluation. Okay, let's go and compile this so you will be able to understand it a little better. See, the answer is build here. Now you can use. So first you have to build. I have kept this much big message so that you can understand it a little better. Before building you cannot use it. There is a dependency. First this function should be called, and after that this function should be called. Okay, so you should not keep it like this. The only guarantee which you get in this scenario, in both of this scenario, is that this function will always be called once both of the functions are done. Okay, but order is not fixed, which will get executed first. But the only thing which is fixed is this function will not be called until unless these both functions are called and returned from their places. Okay, once the value is ready at both the places, then only this function will be called, and the same for this one also. Okay, so as we can see here, first we are calling this one, so this build is getting called first. After that we are, it is calling this use. Okay, this one, and we are just passing 1 and 1 to this and just printing that. This is not the important point what I'm writing here. The only important point is there is no order of evaluation of your function parameters. Okay, so if someone asks what is the order of the evaluation of your function parameter, you say there is undefined. Okay, so I think I'm done here. Let's look at the next question. How would you return more than one value from a function? So as you can see here, there is one values variable v, and it is taking whatever is coming from here, and I'm passing true and false. And this is how we get it, and the output would exactly look what you are expecting here. So let's look at the output now. So this is compiled version of the code, and yeah, the answer is 1x, y, rupesh and all that. Okay, this is okay. This is how we do this, but I wanted to show you this tuple thing. This is totally new. So let's look at the second one. So this is the second example. Here you don't need any structure or class or anything in order to return multiple values from a function. This is the function. Actually everything is just same. Actually three things are new here. This tuple type, this make tuple function, and this tie. Okay, and I could have used that get function also. So okay, no problem, we'll use that also. After showing this example, I will show you another way of doing the same thing. Okay, so for now you understand, you are calling this function with this true is coming here, you are making this flag true, this will get executed. It will create tuple of 1, x and rupesh. This tuple is of this type, so we are happily returning this whole tuple into this tie, num, code and name. How beautiful it is. Like first value is some integer, so this is num, which is integer, code is character and name is string. So yes, you can do this. It can directly bind the variable with the return values. Okay, and you can just simply print those values and it will print that. So we can go ahead and compile this code. It compiled successfully and run. Yeah, so it is exactly the similar what we were doing with the help of structure. Okay, this was the output of structure and this is the output of this tuple. But if you recall structure, you had to do few things. So this is the example that okay, I will comment Okay, I'll just remove this comment here. See, you have to take this values variable, you have to access them with the help of this dot operator, okay? But here you are not supposed to do anything like that. We are just simply binding these values and you are good to go, okay? This is, you can say, a fancy way of doing the same thing what we were doing traditionally in older C++, okay? And this is possible because of this tie only. And there is another way of doing the same thing here. So to show you that, I'll have to write some another bunch of code here. So no problem, I'll write that. Let's suppose you are getting this function like auto and some v and this function, and you are returning it like this. So this auto will get replaced with this type, whatever the type of this return type this function is, okay? So no need to panic. If you don't know, you can search in my video series, you will get what is this auto and how to use this, okay? Or I will give you the link in the description field. So we are done here. Now we want to initialize this num with v dot get 0th location of, no, it is not like this, it is std get 0th location of v. It works like this, okay? Code is equal to std get, I'll just remove this and we can check whether it is working or not, okay? You can see, we'll run this, it will run 1x rupees, okay? So this is also one of the way to get the values from this v, okay? And this v is of type auto, I mean this one. So we can just simply replace this whole thing here. Don't get confused with this auto man, okay? We can compile this again, we'll run this, the same thing, okay? So I'll better keep this auto only because it is nicely looking code, otherwise you can see that it is looking like, wow, what is this whole thing? This is very simple, okay? And we must use this one. So I think I'm done here. Let's look at the next video. And if you like the video, don't forget to hit the like button. I'll see you in the next video. And this question is how this static variable behave in case of template classes or template functions. We all know what is the use of static variables. It is local to the scope, like you cannot access this variable outside this printf, and this will be alive throughout the program for this function, okay? And the same is applicable for the classes also. All the objects will share the same static variable. But what if it is a template function and template class? We all know what is the meaning of templatization. Like if you will be writing it like print 1, then this whole function will get replaced with the I mean 1, which is an integer type. So this t will be replaced with integer here, okay? And this is character, so this will get replaced with the character, this t, and this is a float value, so it will be replaced with the double, okay? So there will be 3 printf functions after compiling this, okay? But this static variable will be common for all those 3 functions or will be separately available for all the different print functions. We'll see that only. The question is that only, okay? So let's look at the function case here. We'll see the class case also. So I will just compile and check that. So this is compiled. Now we will execute this. 11, 11, 11. So what did you expected? Maybe you expected the same or different. So what is this 11, 11 and 11? So as I told, the printf is executed 3 times, but different printf were executed. Here we all know there was 3 printf instantiation. So on the basis of this call, compiler will generate 3 printf, and this printf will call integer version of the printf, where this will have like the whole thing will be like this only, but instead of t it will have integer return that, okay? And for this x there will be some character here, and this float value there will be some double like this, okay? And this static will be different for all the functions, okay? It is not going to be common. That's why it is printing 11 and 11 and 11. If it would have been common for all the functions, it would have print like 11, 12 and 13. It means this is not common, and the same case is applicable for classes also, okay?
So I'll show you the class example here. And yeah, I wanted to show you that it is really local to every function. We can do it like this. If we are going to call that integer version of function 2 times, then first time it will be 11, then 12, then 11 and 11. So let's go ahead and compile that, run that. See, 11, 12, 11, 11. Okay. So this static variable var is different for all the instantiated functions. Clear? Let's move to the class example here. I will change this t to t, this integer to t, and maybe we are good to go anywhere. This t is not there, right? So this play plus, and we are good. So let's go and check the correctness here. Yeah, it is compiling. We will run this. And it is running 1 and 1. So now it is for sure that it will be instantiated 2 times. Once this t will be integer and another time this t will be float. Okay, so this whole class will be returned 2 times with integer here and with float here, and the same case will be here for definition of this variable also. Okay, so as we can see here, this is 1 and 1. If this would have been common for all the classes, then once we incremented this variable and again we are instantiating this class, and if we are printing the same function, which we might think that okay, now it will increment by 1, so it should be 2, but it is not 2. Okay, I think you got the point here. And yeah, as I showed you, for that purpose I will create another like p1 and p1 dot print value. So we'll see that it is really the way I'm telling you. See, 1 2 1. Okay, why this is 2? Because you have instantiated the same class 2 times. So now you are going to share the same static variable in case of integer. Okay, so I think we are good to go for the next video. Thanks for watching. I'll see you in the next video. And this question is how comma operator work, like it initializes in sequence or it executes from right to left or left to right, what it does. So we'll try to solve that question here. Okay, so for that I need some data. I have 2-3 examples, so just don't run away after watching only one example. Okay, so in order to show you that, I have this v1 v2, and v1 is going to be initialized with these 3 and v2 is going to be initialized with this again 1 2 3, but in this bracket, and after that we can just simply print them. So v1 and after that v2. Okay, after printing we will understand what is this whole thing, why this v1 will have some another value and v2 will have some another value. So let's go ahead and compile this one now. So this is again this g++, enter. So the answer is 1 and 3. Why v1 is holding 1 and v2 is holding 3? It's because you didn't notice this. Like this is one statement here, this is another statement, this is another statement. Okay, so this statement executed, then this statement executed, then this statement executed. So the result of this statement execution was initialization of 1 to v1. But here there is no result, like you are going to execute this one, but it's just a number, right? So you can just keep it like this also. And to show you more, like you can have something like this, like 5 6 like this. There is no problem writing like this. So compiling for sure, see there is no error in this. So these all things are single statement and there is no error, so there is no problem in this. Okay, so as we was telling that 1 is going to get initialized into v1, and this is another statement, this is another statement, and the result of these 2 and 3 is nothing. These are the just simple integral constants. But this v2 is going to get initialized with this whole single statement, and this single statement is containing 3 different statements, and comma operator start from left to right. So this one will execute first, then this 2 will execute first, and then 3 will execute first. So in the same case here, 1 will execute first, 2 will execute first, and the last whatever was executed will get assigned to this v2. That's why we are getting values like 1 and 3. Okay,
don't just run away. I have another examples which will make your doubts more clear. So we can use functions like some function, it is returning some values like 1, 2, 3. Yes, it is possible, and I'll just simply print those values like cout function, and let's go and compile this. Answer is 3. As I told, comma operator executes from left to right. It executed 1, 2, 3. Then the result, whatever is assigned, is the always last one. So that's why you are getting 3 in this case. This whole thing is one expression now. Even though you write it like this or not, still it is one expression, because return cannot return 2. So return will always consider whatever is there in this position as single statement, and inside that statement there could be lots of statement with comma separation, and the last one will be returned. Okay, so this is how it works. So if you will apply this, we can check that it is working the same way. So there is no need to give this bracket here, because as I told, return always return only single variable like integer, single entity, and even if you don't write this one here, this whole thing is considered a single entity only. But when it is going inside further, it is seeing that okay, there are 3 different statements separated with comma, so it will execute this one first, then this one, then whatever the value it is getting after executing this one, it will just return that. So it is getting 3, it is getting return 3 only. Okay, so that's how it is working. So I hope you enjoyed the video, and if you have any doubt, please ask, or if you have some another examples you can share, I may include in another videos. Thanks for watching. We'll see you in the next video. So the question is, where is the best suited place that enum will fit in? Okay, or in other words, you can say, what is the best place to use enum? So the answer for that is here. Use enum when you are dealing with some limited set of values. Okay, otherwise don't use that. And for example, you can take like a function which takes limited set of values. I mean one value out of set of different values. Okay, so what do I mean by that? I mean this. There is a function. First we will create enum. So it is sure that I'll be creating enum class only, like color or something. We can go for red, green and blue, and you can give one extra comma here, there is no problem. Okay, so this is ready. Now let's suppose there is one function, we'll call it function. It takes color as a type. Okay, and it does something with that type. I don't know what. We can have switch, it will go inside that, and case, nothing but color red. If it is color red, we will print red, and the same for others. So if there is a situation like this, that your some function will take only some set of values, then only you go for enum. If your function can take integer value, then don't go for integer. I mean, don't go for this enum, sorry, because integer can be anything, whatever the range is defined, like 4 byte and 8 byte. In between that, it can be anything. But here you want either red, green or blue, not anything else. Okay, so we can just simply check this case. Color C is equal to color red, and I will pass this into this function C. Okay, and we can compile this. This is G++A running red. Okay, so I think we're done here. Thanks for watching. I'll see you in the next video. This is really a very famous interview question, like what is compiler, linker and loader. Okay, so there are lots of ways to ask this same question. So I have got 2 diagrams. This is one diagram and this is another diagram, this one. So I'll try to explain with this diagram first, then we'll go to the next diagram. Okay, so compiler is not just one single entity. It has lots of modules inside that. Okay, so first you have written one source code So let's suppose source code 1, 2 and 3. Let's suppose there are 3 CPP files or C files. You will feed that file into the compiler, and that compiler will create object code. Like if you are just simply compiling it, you will get .o file. Okay, so that .o file is nothing but the object of your particular file. I mean the object file, okay, of your particular source code. Like suppose if you are having this source code name like 1.cpp, then the output of this compiled version of code would be like 1.o. Okay, so this shows that this is the object file of this 1.cpp file. Okay, so once you will get that .object file, the linker comes into the picture. Linker will take all the object files along with the library files. You might be taking some libraries, like if you have included math library or some another external library, what you write here using like has include, or you link it when you're compiling. So you might have seen people linking math library like this. Like suppose if you are having some code, you can compile it like code.cpp, and here you will give lm. This L stands for library and this M is for math library. So this library you are giving it at compile time. Okay, so this library will also come into this phase. So that library will come, object files will come, linker will get all these things and will link together. Okay, and linker create executables, what you see in the end. Let's suppose you compile this, you get some executable. That executable is the result of linker. If linker fails, you might have seen lots of errors like undefined reference. That undefined reference come from this linker. Okay, and there is no undefined error or everything goes well till now, till here, it will create executable. And when you run that program, when you double click that or run that program, that loader come into the picture, and this loader is not the part of your compiler or anything. This loader is the part of your operating system. In operating system, this loader will load that into your RAM and it will put into the ready queue. I will not go into the operating system much, so just try to understand. You are done with the executable. If you will run this executable, loader will load into the memory and your program will start running. So this was the first diagram. This was very basic diagram what people use. I have this another diagram also. Here you can see you have some editor or some IDE. You write source code in that. The source code is in form of .cpp and .h. That .cpp and .h goes into the pre-processing state. Okay, this pre-processing compiler and assembler and linker, from here to here we call compiler. It is really a confusing that saying these 4 stages a single compiler, and in second phase you say compiler. Okay, this is confusing enough, but this is the way it is. People get confused, but once you will get experience, you will understand what is the difference between this whole compiler and what is the difference in this one single entity of the compiler. Okay, so this comes under like lots of errors are there in program, like lexical error or semantic error. Those error comes into check with this compiler, I mean this phase. Okay, there are lexical analyzer, semantic analyzer, so those things comes under this one. If you don't know lexical analyzer and semantic analyzer and all that, and tokenizer, forget about that. I will explain briefly about how the compilation goes. So you will get the preprocessor first in the phase. So it will take .cpp and .h file and it will do the pre-processing, like it will remove your comments from the code. Okay, because that comment is of no use for your operating system to understand the program. It needs only the actual program, no need of comments in that. It includes your included file, like we do this hash include IO stream. So this is nothing but a file. It is taking that file and pasting it here, just here. It is simply taking the content of this file and pasting here. Yes, it is total copy and paste. Okay, so once it will paste, it will move to the next thing. It will see that, okay, using namespace, okay, fine. It will go here, 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 like that. And let's suppose you are having some comment here like I am writing main function here, then this comment will get erased. Okay, there won't be any comment after the pre-processing state. Okay, so the pre-processing state will do all these things, and it will replace the symbols also. Like if you have used any macros, it will replace all those macros at that phase. Okay, and if you don't know, I will give you a simple example in that situation. I know I'm going to make this video a little more lengthy, but it's okay. Max or add, and it can have x and y, x plus y, and let's suppose you are using that somewhere here like and 1 comma 2, then we all know this thing will get replaced with x plus 1. So when this pre-processing state will over, this x plus 1 means 1 plus 2 will get returned here. Okay, so 1 plus 2, it will look like this after this phase. Okay, after this pre-processing state is finished. Okay, so once this preprocessor stage is finished, it will go to the compiler phase, and compiler phase is having tokenizer, lexical analyzer, semantic analyzer, and first of all it will convert into abstract syntax tree so that it can derive the meaning out of your code. So there are lots of phases, so I'm not going to explain the compiler. I may include in some another video, but the purpose of this video is whole phase of your compilation. So once your compiler is done and your code is okay, it will generate the assembly code. Yes, your compiler is responsible for creating assembly code out of your original code, I mean the CPP code. Once that assembly is done, it will feed that assembly into the assembler. Okay, and that assembler will read that assembly and create object code. Okay, and that object code will go into the linker, and some external libraries like static libraries like .lib or .a in Linux, it is .a, will go into linker, and once linker is done, it will see all the code what you have written, and if you have used some static library, it will see the library is there, definition is available, everything is fine. It will pass that and it will create the exe. So you are done with your compilation and you are ready with your executable. Now you can run it. So once you will run this exe here, it's up to you, you want to run this or not. So if you run this, the loader will come into the picture, and loader load your program and any dynamic library like .so or .dll in case of Windows and .so in Linux at runtime. It will take these libraries at runtime and load it. Okay, so once everything is perfect, it will load into the operating system. So this is how this whole thing goes. And if you want to see the compiled version of this one, I can show you that. I mean the whole files like .i, .s, .o. So there is command in Linux. I don't know about the Windows what is there. It is there in Windows as well. You have to search for that. I don't know. But in Linux I know that. So we can simply go to this place. Where is this place? I don't remember that. G++. Compiler, linker and loader. This double dash save temp. Okay, and you are good to go. You can just simply compile this. Oh, actually you need to give this save temp here dash. Oh, I didn't comment it out this whole thing. So we need to comment this first. Commented and do this. So if you will see here, my program name was this compiler linker loader .cpp. Okay, this is the code here, and once I did compilation with this option save temp, it will give you .i, .o, .s. Okay, so this is your object file, this is your pre-processed file, and this is your assemble file. Okay, we can open that and we can see what is this. So first we will open compiler linker loader .i. Once you will open that, you will see this whole bunch of code. It is really very big code, and you will have your whole program in the bottom. Like if you want to go into the bottom, press Shift G in this, it will go. See, this is your program, and using namespace is this, and the whole content, like from here to the whole top, it is coming from iostream.h. Sorry, iostream, there is no .h in that. So this whole thing is just copied and pasted here, okay, in this file, as I said in the beginning when I was explaining. And did you notice that comment is gone? So let me check whether that comment is still there or not. Okay, yeah, even this comment is also not there. Okay, that comment is not there, no problem. I can simply write some comment, and this comment will not be there. We can check that. I will just compile again with the same option, and we will check that .ii file. Press Shift G, will come in the bottom, and see in between this using namespace std and the int main, we have this comment also, but in this comment is not there, and even this whole comment is also gone from the bottom of your main. See, after main nothing is there. If I'll press down button, nothing is coming in this. Okay, so you can analyze the intermediate files. You can open other files also, like .o file. It is not readable file actually, but this is how it looks like. Okay, and you can open that assembly file also, that is readable, but I mean you need a good knowledge about assembly. Okay, then only you can understand what is happening here. And this is your actual code, guys. This is the code. Okay, see here, I love string. This is a string part. There are lots of section in the code, like text section and global section. Okay, so this is how it looks like. So I think I'm pretty much done here. So if you have any question, please ask. I'll be very happy to answer that, and maybe in future I will include much more deeper videos for this. For now, enjoy this video. Thanks for watching. I'll see you in the next video. Bye bye.
The question is how to print something n number of times without using loop or recursion or any iterative way. Okay, and the answer is using constructor and the array trick. Okay, so we'll see how it works. So this is your base class. There is some class you have to create, and inside constructor you just print that value. I mean whatever the value you are asked to print. Okay, so you print that value here and you create an array of that size. So size is like if someone is asking you to print 10 times, then you just give 10. So what is happening here? It will call constructor 10 times. Okay, so because it is required to create an array of base of 10 size, so this constructor should be called 10 times. Okay, so that's how you end up calling this constructor 10 times, and you print this bingo 10 times. Okay, so in an interview you might be asked like you can print something without using loop or recursion n number of time. Okay, so the n is defined here. So this I could just simply write it like this: integer n is equal to 10 here. Okay, so we'll see, it will run. Yeah, see, this bingo is coming 10 times here. Okay, so that's it. Thanks for watching, and make sure you check out my other videos so that you can prepare well. Bye bye. And the question is how to call some function before main. There are lots of ways to do that. I'll be explaining one of the way, okay, which is very famous in C++. So this is the way you are having one main function and you want to call some function, let's say this function, before this main even start. Okay, so how to do that? So the trick is you create some class, and in that class constructor you write that function and create a global variable, because global variable is always created before main starts. Okay, so creation will cause this constructor to be called, and this constructor will end up calling this function, and you will call this function. Okay, so we'll see that. We'll compile the code, we'll run. So if you notice here, this is inside base and then inside main. Okay, I should have written like inside function. Okay, before I plan to keep this in here, later I kept it inside this. Okay, so this is the basic idea actually. See, now it is first going to inside function and then it is going to main. Okay, you are not calling function here, but still it is calling that function. Okay, so this is the trick. This is first trick. There is another trick also. So for that you need to have one static variable of class. So we will just remove this, and some static means you can just keep simply static something like integer static variable.
Okay, and we all know that if we are creating some static variable here, so this is kind of declaration, we have to define it. So I'll define that it is in base. So static variable is equal to function. So now this time, as this is static variable, it will get created first. Okay, so this will end up calling this function, okay, because it has to be initialized first. So initialization part, I mean the value for this particular static variable is coming from this function. Okay, so I need to change this also. We have to make this integer, and we should return something like, we can return just 10. So 10 will be assigned here. Okay, so we'll just go ahead and check whether it is working or not. Yeah, it is working, and see the same. So that's it, I'm done here. Thanks for watching, and make sure you go and check out my other videos. Bye bye. And the question is, what is diamond problem in C++? And this question is generally asked for freshers interview. Okay, so what do you mean by diamond problem here? So if you see the class hierarchy here, I'm inheriting this A into this B and C both. A is coming into B and C, and these two B and C are inherited into this D. So it is actually looking like this. A is coming to B and C, and both B and C are coming to D. So this is looking like a diamond. Okay, that's why this is called diamond problem. And what is the problem in this? The problem is this A is coming 2 times in this D. If you inherit something, then accept that constructor and destructor things come from here to here. Okay, and 2 times A will be there, and you are again inheriting B and C into D. That's why the copy of A will be 2 times in this D. Okay, so here is some example I have given. The A object will have its only A memory, but B, as B is inheriting A also, then B will have this B integer type, and A will also be there in that. Okay, so if you will print the size of B, it will print 4 plus 4, 8 bytes. Okay, so if you see B's object memory layout will be A and B, and C will be again A will be there in C, and the C part will be there in that C again. Okay, and what will happen in D? As you are inheriting B and C both, then the both will come here. So what is this? A and B. So this A and B will come, and A and C will come. Okay, and this is the D part of that class. Okay, so if you see here, there are 2 A in this. Okay, so there comes the ambiguity problem. If you will try to access this A, which A should be accessed? Either this A or this A, and this is called diamond problem. Okay, so this diamond problem doesn't comes until unless you just touch that A, I mean the ambiguity variable. Okay, so we'll see that if you create this and you will compile it, it won't create any problem. Now if you will use it, then only it will create the problem. So I will assign something to that. Now we'll compile that, and it will say error request for member A which is ambiguous. Okay, so this statement is creating problem. This statement, okay, not this statement. If you are not accessing this A which is coming from A, which is causing the problem here, I mean the ambiguity problem, if you are using this D, then it is okay. So I can just show you that. In case of D it's okay, in case of B it's okay, in case of C it's okay. Okay, if I will do it like this and I will compile, it will successfully compile. So there is no problem in accessing B, C and D, because B is unique, C is unique, and D is also unique. The only problem is A. Okay, A is 2 times. That's why if we are accessing A here like this, it is creating problem. Okay, if this is A, we will compile, it will say the error. Okay, so how to solve this problem? The solution to this is you need to inherit this A virtually. So what is the syntax of that? Okay, this is the syntax to inherit some class virtual. You will write this virtual in this case, and now if you will compile, it will compile successfully. So let's go ahead and check that. See, it compiled successfully and you are using A. Now try to understand what is happening here after writing this virtual in this case. Okay, so if you are writing virtual in inheritance case, and when the compiler will go and create the memory layout for this D, it won't create this A 2 times. Okay, because it knows that you are inheriting it virtually, so the A will come into D virtually. Okay, virtually means it won't be 2 times, it will be 1 time only. Okay, it will be separately there for B and C. Okay, so there won't be any changes here. It will be A only, and this is also going to be A. But here it will remove either this A or this A. So that is the way to solve this problem. Okay, so that's it. This is diamond problem, and this is the solution for that, virtual inheritance. Okay, now you are accessing A, and it is working also. You can just simply check that. See, it compiled. So you can access this. If you would have not written this virtual, it won't allow you to access A here. We will just compile and check that. See, the error is coming. So now I'm done here. Thanks for watching, and make sure you go and check out playlist for similar videos like this. Bye bye. And the question is, what is static and dynamic binding in C++? And the answer is, this is function call mechanism determined at compile time or runtime. Okay, so we'll see what is that compile time and runtime thing is. So first of all, if function calling is known at compile time, then it is called static binding. So we have got two words here, static and dynamic. So what do we mean by static here? So first we'll understand that. If your function is known at compile time, that it is fixed. If you are calling some function like this is base object and you are calling function on that, so this is your base class and this is that function. So this is known at compile time, that okay, you are telling that I will be calling function and this is that function. So it is okay, no problem. Okay, so this is what static binding is. You are telling some function I will be calling and this is that function. So it is very clear. Okay, I mean, it is pretty clean that you will be calling some function and that function is inside base. Okay, so that is static binding. And what is this dynamic binding? Dynamic binding is achieved at runtime. Okay, when you actually call some function, it will change at runtime. Okay, we'll see that how it works. So if you notice here, this is my general function. So I'm just passing sometime base, like this is base pointer and I'm assigning it with this new base. So sometime I'm passing this base pointer and another time I'm passing this derived pointer. So this function should be called, and depending on what object this object variable is pointing at, this function will be called. So let's say first time I'm passing this base object here, so this pointer will be pointing to some base object, then this function of base should be called here. Okay, and next time I am passing this derived, so in that case derived is there inside in this object, so that function of derived should be called. Okay, and that whole thing is achieved just because of this virtual keyword here. Okay, no need to write virtual keyword here, you just supposed to write virtual keyword here only. Okay, and we'll be done. So we'll just run this code and we'll see it is working. I'll just compile this and run. See, first time it is calling base function, next time it is calling derived function. Okay, and now let's suppose if I will remove this virtual here, okay, and I'll just again compile and run. See, this is base function, base function. What is happening here? You are doing like this, virtual here. You are telling that I want virtual behavior. I mean the runtime behavior. And what that means? It means whenever base pointer point to derived class object and some function is derived from base class into the derived class with virtual keyword, that time you call derived function, not the base function. Okay, so this is what we have achieved here. So as you can see, I have kept this again. We'll just go ahead and compile and we'll run. We'll see that okay, base function and derived function is achieved. So this is what the dynamic binding is. Okay, I'm just compiling this code till this. Yes, I have compiled. So what compiler is seeing, one object is there. What is the type of the object? It's base. Okay, so base have function here. That's it. Now compiler don't want to see at runtime whether I'll be actually calling this function or this function. No, compiler won't check that. Compiler will only check this thing. Base pointer is calling function. That function is there inside base. That's enough. Okay, no problem. So till now this is static binding. And when you are passing derived and you are calling function and you have kept this virtual here, so that time it is calling derived function. This is runtime. Okay, You saw we didn't change anything inside this function, and one time it end up calling this function and another time it is calling this function. So this is runtime. Okay, you are achieving this at runtime, not compile time. Okay, so compile time is just this one only. You are calling this function on this object. What is the type of the object? It is pointed to the base, and base has this function. That's it. So compiler is thinking we'll be calling this function, but at runtime sometime we are calling this function also. So that is that dynamic binding, okay, that we are achieving at runtime, not compile time. Okay, so I think I'm done here. Thanks for watching.
And the question is how to overload pre and post operator in C++. And I have taken this example. This is an integer class. This you can call a wrapper class of this primitive integer data type. And this is how I'm going to explain you the question here. Okay, so in this case is pre-increment case, and this is how we do post increment. Okay, so let's take an example here. You have created an object of this integer class. So this is one integer class here, and you have taken one object and you are assigning 100 into that. So this is your constructor. You are assigning 100 into that, and you have assigned value to the element. So this is the element, this is the data member of this class, and now last you are printing that. So we'll just compile and run so we can analyze the output of this. So this is printing 100 for this. So this is quite obvious. Now we'll incorporate this post and pre-increment logic here. So I++ will do, and simultaneously we can check the value here. Like if it is post, we all know that if I will print the value at this line only, then it will not print the updated value, because this is post increment. Okay, so it will print here. Okay, so we can just compile and run for that case. So see, when you created the object, you assigned 100 in that, and you did post increment on that operator, and you print that operator at that line only, then it is giving you 100 only. Okay, and if you are printing the same I here, then it is giving you the updated value. So this is what generally happens when you use primitive data type. And we can simply check the case of pre here. So instead of this post, I can just use this pre here. So what happens when we pre-increment? When we pre-increment, data gets updated at that time only. At that line only. Okay. So if we will print this one, we'll get 101. So let's compile and check that also. So see, 101 and 101. So we are printing two times, and this time it is giving you the updated value. So how we are achieving that? Let's try to understand. So first of all, I will tell you how the compiler differentiate whether I should call pre-increment or post-increment. So this is how it is done. If you pass an integer parameter to this operator, then it is considered as post-increment. Compiler always needs some way to discriminate whether you have done pre or post. So if it is post, then which operator should be called, because both are this plus operator. Okay, if you have written plus operator here or here, so how to differentiate, okay, which function to call? Okay, so this is one dummy variable we pass, and if you have written post, then this function will be called, and if you have written here pre-increment, then this function will be called. Okay, this function. So first we'll check the pre-increment case. So in case of pre-increment, it will take the element value and increment that and return the object. And on that same object, you are calling some function which is print value. So you are printing the element of that particular object what you get here by this return. Okay, so you will be printing the updated value. As you can see, you have updated the element here. Okay, but in case of post increment, when you do this post increment, you call this one, and this is how it is achieved. Okay, so this is the way we deal with this post increment. So first we take the copy of your this operator. So here you notice there are two objects. Okay, first object you called, which is I. Now this is converted, this you can treat as this here, and you created another object which is temporary object. So first you assign your I, which was coming from here, to this temporary,
Now you are incrementing the value with the help of this plus and you are returning temp. You are not returning this. In pre case you was returning this only, but you are returning temp here because you don't want to return the updated value. It is post increment, not the pre increment. Okay, so you will return the old value and you have updated the value also. Okay, so in this case we can see it won't get the updated value here. We can just compile and we can check. It didn't get the updated value here. Even if you incremented it, it didn't get updated here. It will always get updated here only. So this is the trick we do to achieve this post and pre-increment of objects. Okay, so I'm done here. Thanks for watching and make sure you go and check out my other videos so that you can prepare well. Thanks. Bye bye. And the question is how to set, clear, toggle, check and change a single bit. Okay, and the answer for that is I'll be explaining one by one. So first I'll be explaining how to set one bit. Okay, so this is your number. Okay, you will be setting some bit in this number. Okay, and the bit position is this one, which means you are setting second bit. So this is 0th bit, this is first bit, and this is second bit, and this is third bit. Okay, so you will be setting second bit, which means this bit. So if you will set this bit, it will become like this after setting. Okay, so this is nothing but 7. So if we will compile and check what it will print, we'll verify that first. We'll compile and we'll check. As you can see, it is giving 7. So number is 3. You are changing the number using bitwise operator. Okay, how it is working, we'll see that. You have taken the position 2 and you are doing left shift on this 1. So 1 is having this binary representation. Okay, in 4 bit. So if you will do 2 times left shift, it will go here. Okay, so this will be the result of this one. Okay, so assume you have written this one here, and now what you are doing? You are doing OR operation on this number. So it is nothing but you are doing like this. Number is 3, which is 0011, and you are doing OR with 0100. So we can see it will result in 3 times 1. So instead of writing it like this, I can just simply write it little bit like this so that you will be able to understand little better. 01111. So these two ORing will result 1, these two ORing will result 1, and these two ORing will result 1. So you see, this is the result, and you have achieved 7 with this. So you already saw that the result is 7. So this is how we set some bit of this number. Okay, so now we'll unset one bit, okay, using this AND operator, and this is how we do that. Our number is as usual 3 here, and this is the bit representation for that. We are unsetting this first bit, this bit. If we will make this bit 0, it will be 1. So this is how we do that. You know, you are doing left shift to this 1. So as I already explained, you will be getting some output like this. This is the output of this particular thing, and this negation shows that you are inverting all the bits what is there. Okay, so you will invert the whole bit set here. So the result will be 1101. This is the result. And now you are doing AND operation with number. And what is our number here? Our number is 3. So the 0011. So if you do AND operation here, so the result will be something like this. AND with 100, and with 10 again 0, and with 01 again 0, and with 11 it will be 1. So you see, you have unset this bit here. Okay, so if you will unset this bit, the answer will be 1 only. We'll just go and compile and check that. See, we are getting 1 here. Okay, so this is how we do this unset bit operation. Now I'll move further. So this is the example of toggle one bit. So toggling means if it is 0, you will make 1. If it is 1, you will make 0. So this is your number as usual, and your bit position, what you are going to toggle is 0. So if you will left shift 1 by 0 time, it will end up as 1 only. Okay, so that is pretty obvious that if you will do this left shift 0 time means no time, then it will result as this one only. We are using here XOR, and if you remember, XOR operation is If 2 bits are equal, it will return 0. If 2 bits are not equal, it will return 1. Okay, so we are doing XOR operation with this number. So 0011. So as I told, XOR returns 0 in equal case. Okay, so this is equal, so it will return 0. These two are equal, it will return 0. And these two are not equal. This is 0, this is 1. So this will return 1. And again this is equal, 1 and 1. So it will return 0. So you can see you have achieved toggle bit operation and you have toggled the 0th bit here. So you have toggled this 0th bit, which is 1, and now it has become this one. So we can just compile and check this code also. We'll compile and we'll run. So this is 2, okay, and we are getting 2 here. So this is also done. Let's move to another. Now this question is, how will you check some bit? Like what is the bit value at second position, or what is the bit value at third position or 0th position? So this is how we do that. So this is very simple thing. You will have check position like 2. You want to check the second position of this one, which is 0. So we will get 0 here. Okay, we will verify and check that. As you can see, we are getting 0 here. So how this is working? You are getting this bit position and you are doing right shift on that number by bit position. So obviously that bit will reach here. Okay, and you are doing AND with 1, which means you are extracting out that bit. So I will just explain and I will just write like this. Like this is your number 0011. You did 2 time right shift. Okay, so the result will be 0000. This 1 will also go off. Okay, so this will be the result. Okay, and if you notice this 0 is here now. Okay, and what you are doing AND operation with 1. So how 1 looks like? 1 look like this. Okay, and if you will do AND operation, as this all are 0, you will end up getting 0 only. Okay, so this will be the output for you. This, okay, and as you saw, we are getting 0 only. If you want to check this 0th position or 1 position, so first I will go and check the 1 position. So in that case, you should be getting 1, because at 1 position, this is 0th position, this is 1 position. So at 1th position, you are having 1. So we should get 1 here. So we'll compile and check. As you can see, we are getting 1. Okay, so this is how this checking a bit work. Let's move to another change. Now this question is, how you will change nth bit to bit value. Like you are having some bit value like 0 or 1. It cannot be anything else because a binary is only 0 and 1. So you will be having either 0 or 1 in this bit value, and you want to change the nth position of your binary representation. Let's say you want to change the second place. Okay, so this n is 2. So you want to change this one with bit value which is 1. So this is how this will work. I'll compile and check whether it is working or not. So as you can see, if we will set 1 here, then it will become like this, and this is nothing but 7 only. Okay, so this is working correctly. Now let's see how this is working. So first of all, if you know the precedence rule, then this will get executed first. Okay, so AND operation with this one. So first I will write what this is. Okay, so this is your number. So number is nothing but 0011, and you are having this AND operation with this one, which is nothing but 1 left shift by n time. So 2 time. So it will be 001. Sorry, it will be 0100. Okay, and you are having this negation. That means you want to flip all these bit. So this will become like this. 1011. Okay, so you have flipped this bit. Now you want to do the AND operation with this one. So the result of this will be 0011. So you have got 0011 till now up to this. Okay, and now you want to do the OR operation with this one. So we'll calculate this one now here. So this is bit value. Bit value is 1. This is what bit we want to set. Okay, so we will do the left shift that many times, n time. So this is bit and you are doing the left shift that many time. So n is 2. So you will do 2 time left shift on this bit value. So this will be like 0100. So this will be the output of this one. Okay, and as you have output for this one and this one for this one. So you will just simply do the OR operation between these two. So the OR operation between this one and this one will result into something like this. If we will do OR operation with this one, then the result will be 0 1 1. Okay, and 0 1 1 is nothing but 7. So we'll see that how it is giving you the output. So as you can see, this is giving 7. So we have achieved setting second number of bit, which is this one, with 1. Okay, you can do this experiment, like you might be willing to set this 0th position with 0. Okay, so in that case you have to keep this one as 0, and the bit value also you want to keep 0 only. Okay, so if you will make this one 0, then the whole binary representation will become 2. So we shall get 2 here. So yeah, we are getting 2 here. So this is perfect code. I'm done here. Thanks for watching, and make sure you check out my other videos so that you will get so many good videos to prepare for C++ interview. Even if you are fresher or experienced, you can check out my list. Bye bye. Hello friends, this is not any C or C++ interview question. This is just to inform you that whenever you want to check any optimization case, that which code will work fast and which code will work slow, you can use this website godbolt.org. So this will tell you how many assembly instructions are there for your particular code. Okay, so the idea is you can write anything like this, like integer a is equal to 10. So it will create the code for that. So it is giving you color based understanding, so that here, as you can see, this is a green color coming in background. So this particular line is generating these two assembly code. Okay, and this middle one is generating only one line of the assembly code, and this last bracket is generating these 3 assembly code. Okay, so that you can interpret which line is creating how many assembly instructions, and you can decide whether you should use something over something. Okay, so this website I generally use, so thought of informing you guys also, it might be helpful for you. I'll create another video so that I can show you the best use of this website. Okay, so thanks for watching, and if you really like the content, like and subscribe. Bye bye. Hello friends, welcome to another C++ interview question, and this question is, which one is faster among pre-increment and post-increment? So I have brought this website so that we can visualize it, that which one is faster. So we all know that post-increment is little slower because you don't update value at that moment only, you update it later, like you are incrementing this I++ here and simultaneously you are assigning it here. So initially the I is 10, so 10 will go into J++, and later after this, I mean at this line, this I will get 11. Okay, so there was some magic happening inside, we never talk about that. Okay, so I have brought that here. So this is the I++ case, I mean this is post increment and this is pre increment, and this red one, this red line, this line is generating these 4 assembly instructions, I mean 4 lines of assembly instruction, and this pre one, which is this, I don't know, blue, is generating these 3. So pre is generating 3 line and post is generating 4 line. So that is pretty obvious that we can see post is taking more time. Okay, but what is happening inside? So let's look at that. First I++, so that is post increment. Now pay your attention guys, this is nothing but your I. Okay, so as you can see, this RBP -4, this RBP is some value, we are referring that and doing -4 so that we are reaching to our I location, and the same reference and -8, then we are reaching to our jth location. Okay, so consider it, this is I and this is j, and you have assigned 10 to I and 5 to j. Okay, so this 4 is nothing but I. So what you are doing, you are moving your I into some EAX. This EAX is nothing but some register. So what you did, you just copied your value, what was 10, to some register. Okay, now what you did, you are doing this LEA. It is nothing but incrementing this value, I mean this RAX. RAX is nothing but your accumulator register. If you don't know what is the job of accumulator register, you just think of it stores the value of your current address. Okay, that means what you are doing, you was holding this I, right? So I is having 10. So you assume this is 10. So 10 plus 1, 11. That is what we want to do. We want to do plus plus. So here it is 11 and you are moving that 11 into EDX. So this one is having 10 and this one is having 11. Okay. Now what you did move EDX, which is 11, to RBP 4, which is I. So you changed the I here. Okay. Now you have moved the EDX, which was 11. If you notice, you have moved the 11 into I. So I have got changed and it is now 11. Okay. And after that you moved EAX, which was originally 10, to the J. That's how we achieve. Okay. So this is what we all know happens internally, that you will be moving 10 into that and I will get incremented magically. So this is what magic is. Okay. You are assigning 10 into J and you have incremented your accumulator register by 1, which was holding this ith value. So nothing but 10 and plus 1, 11, and you move that 11 to EDX register, and lastly you move that EDX to your 4. 4 is nothing but I. So I is holding 11. Okay. So we are clear till now. This was I plus plus case. In plus plus I case, which is pre-increment, which is faster than I plus plus, we add 1 to 4. So 4 is nothing but I only, you can see here. So we did addition, and how this assembly addition work, you add 1 to this I and store into this. So this is how we should interpret, like you will add this one and this one all together and you will store at this location. So this is how we interpret this add and all that. So you have made this I 11 now. Now what you did, you are moving RBP4, which is now 11, into EAX, some register, and then you are moving that EAX to 8, which is nothing but your J. So the updated value is coming to J here. Okay. So this is how it is being done here. Okay. I think you enjoyed, and please use this website or getting money out of it. Okay. I am just promoting this because I always use this to visualize the assembly code and which one will work fast and which one will work slow. Okay. So maybe it will be helpful for you. So I'm suggesting that. And please check out my other videos for interesting C++ questions like this. Thanks for watching. Bye bye. And the question is, what do you mean by class and object in C++? So this is a fresher interview question, and the answer is, class is user defined data type and object is an instance of class. So we will see what do I mean by user defined and the instance. Okay. First we'll talk about primitive data type. So as we all know, what do I mean by primitive data type? This is primitive data type, whatever C and C++ gives. Okay. So like character is also a primitive data type. Okay. You can just define anything in that. So this is also primitive data type, like integer, float, character, double, all those things are primitive data type, which is already given in C and C++. But what if you want your own data type, like you want to work on something which is not there in that C and C++, which is not ready-madely given by C and C++. Like we do lots of stuff, right? So C and C++ cannot give all the data types what you want because it's your requirement. You have to do your own study and come up with your own data type. So C++ and all other languages are giving a way to define your own data type, which is called user defined data type. Okay. And what is user defined data types? You can create using classes and structures. So I'll be taking this class as an example. So we all know what is rectangle. Rectangle has width and height. So we will set values and we'll get the area of that rectangle. So no need to write this one actually here. Okay. So this particular thing is your user defined data type. You have created a data type which is rectangle. Its name is rectangle and it has parameters like width and height, and it can do the operations like set values and you can get the area of rectangle. Okay. So this is about user defined data type. You might have understood it by now. And now we'll talk about the object. What is object? Object is nothing but a variable. Like you create variable I is equal to 0, right? So this is called simple variable, and when it comes to classes like this, instead of primitive data type, you write class name here like this, and now this I has become object. Okay, before this I was simple variable, now this has become object. Okay, so this is the only difference. We call them variable in case of primitive data type like this, integer, and we call them object if it is class. Okay, like this. You can just simply define it like this, rectangle I. And here comes the real fun. Now you can set any value, like set values. Let's say you want to set 2 and 3, you have set it, and let's say you want to print it like I dot area, then you can just simply print also. So we'll just go ahead and compile that code. See, the area is coming 6. Hello friends, welcome to another C++ interview question, and the question is, what is abstraction in C++? Okay, so answer is, it is an object oriented programming concept that talks about show only the necessary thing. Okay, so there is misconception about data abstraction and data hiding. Lots of people think that both are equal, but they are totally different thing. Okay, so first I will talk about data abstraction here. In next video I will talk about what is data hiding. Okay, so abstraction means you don't want to show how you have implemented something. Okay, like some function, this is your function, you are calculating the area, you just don't want to show how you have calculated it. Okay, so I'll explain you in the layman language. Let's suppose you have some file which we call library. Inside that you can only see what are the functions, like if this is the entity which is this class rectangle, and you can only see what are the possible operations available in this rectangle, like set values and get the area, get width and height. So these are the operations which is possible on this rectangle entity. Okay, you will be able to see only this much. So that is data abstraction. You won't be able to see how something has implemented, like how the area is being calculated. This is very simple thing, so you might think that what is the point of hiding this, how to calculate the area. But let's suppose there is one expensive class, let's say rocket, and you don't want to share how the rocket flies. Okay, so there is one method fly. Okay, and you have written very much complex code in that which you don't want to show to others. Okay, so what you will do, you will compile your code, I mean this class, and convert that into a library, and you will only show that you are having this fly function. You just call the function and this rocket will start flying. Okay, you won't show what is happening inside that, and user won't be able to see that. And the reason could be anything why you don't want to show that. Okay, so hiding the implementation part is called abstraction. Okay, remember this, you're hiding the implementation. Okay, you're not hiding the data. That is a different concept. I will talk about that in my next video. Okay, so that's it, I'm done here. Thanks for watching, and check out my other videos and prepare well. Thanks, bye bye. And the question is, what is data hiding in C++? So it is an object-oriented programming concept that hides the data from the user so that accidental changes can be avoided. So notice this point, guys. We are hiding the data from the user, like this is the data and we have not given any access specifier, so it became private. So we keep private like data only because we don't want accidental change, not because you will avoid hacking or something. Because I have seen people talking about you hide data, like you keep some data as private so that you can avoid the hacking. Okay, that is not related to hacking, that is related to not allowing any accidental change. And what do I mean by accidental change here? So first of all, this is the class, and these are your parameters, what you keep as private. Okay, and we are going to use that rectangle as this object. You have set the width and the height, and you are getting the area. Okay, so what do I mean by data hiding here? I am hiding this data so that accidental changes can be avoided. I am giving the interface or the function to change this width and height here. Okay, so you are setting the height here and you are setting the width here. Instead of giving this function, I could have just simply kept this as public, like I can just do like this. Then user is allowed to use like this, object dot underscore width is equal to 7. Okay, or some -1. Okay, but there is a restriction that this parameter cannot be minus or 0. Okay, so user have changed the value which was not allowed. Okay, so to avoid these type of problem, so like user have created it -1, or user can create it like, can assign it like 0, and which is not allowed. This width cannot be 0. There are some restriction, okay, over these parameters. So how would you impose those restriction? You impose those restriction by keeping all these data member as private here, okay, and giving the interface. So when you will set the width, this width will go here, and we will check if width is not equal to 0 and width is greater than 0, that means not the negative value, then only we are going to set the width. Otherwise we won't send, or we can just simply send some message or print some message like it is invalid value like this. Like in else case we will do that. It is invalid value. Okay, so this is the only reason we use data hiding. We don't want user to accidentally change these parameters so that whole thing will get corrupt. Okay, and the question is, what is data encapsulation? So wait a minute, data encapsulation in C++. Okay, so the answer to that is, it is an object-oriented programming concept that binds data with the function, and function uses data and manipulates that. Okay, so there are two things, one is data and another one is function, and you have inserted data and function all together into one thing, which could be a class or a structure, this one. Okay, so this is your data, okay, width and height of the rectangle, which is the pure data, and these are the operations you want to perform on that data. So encapsulation is nothing but putting all these together, like data and the operations which you want to perform on that data. You will keep these two into one thing, which could be a class or structure. So this particular thing is called data encapsulation. You have encapsulated these two things into the rectangle. Okay, so that is what data encapsulation is. Thanks for watching, and check out other videos and prepare well. Bye bye. And the question is, what is good way to count number of set bits? Number of ones present in binary bit in some variable using C and C++. Okay, so this is the example. There are two ways. I have included two ways only. There are lots of ways. This is the simple way. First we will see the simple way here, and the way is, you will be iterating over number. So this is your number. This is, I am assigning with 7. So if you don't know, you might be knowing that this is the binary representation of this 7. Okay, there are 3 1. So we want 3 as output, because we are looking for how many 1 is there in that number, in this variable. Okay, so we'll loop through that number. So first of all, this number is 7, so it is not 0, so it will go inside this loop. And what we are doing later on, we are just doing the AND operation with 1, which means we are doing something like this. We have this bit representation which is 7, so this is 7 here. We will be doing AND with 1, so this is 1. So 7 AND with 1, we will end up getting 1 only. So this will be the output. So you are getting 1 as output here, and then you are adding that 1 to the count. So initially the count is 0, so it will become 1 now. Now you are doing this right shift by 1. So this number will get right shifted. So it will look something like this. After getting right shift, it will look like this. So this whole thing will get shifted right side. Okay, this side, and this last bit will go off. Okay, and at 4th position 0 will come. So this is the result of this statement here. Okay, after that you will do again this checking. Is this number is 0? No, it is not 0. That means we will again come inside and you will do that operation again. What you will do? You will do the AND operation with this one. So again 1 will be the output. You can see 1 into 1, 1 will come, and 1 and 0, 0 will come, 0 0 0 0. So result will be this only. Okay, so again that 1 will get added to count. So this time it became 2. Again you will do this number with right shift, then you will get this number. Okay, you will get this number. Now again you will do the AND operation with this. So AND with 1 will produce the same output. Like if you will do the AND with this one again, then you will get the same thing. So you will again end up adding 1 to the count. So you counted up to 3 now. And now if you will do again one right shift, it will become 0. So this 1 will go off, then it will become 0, and you will come out from loop because of this condition. Okay, so if you will print, it will print 3. So we'll check that. Oh, I forget to remove this. We can just now check. Yeah, see, this count is getting as 3. This is the simple way. Okay, it will take so many iterations to complete that, but there is one good way to achieve, and that is called brain Cunningham way. Okay, and we'll see how this will work. So I have commented out everything. I'll just make sure it is working correctly. Yeah, 3. If you notice here, we are again iterating only, but this time you are going to iterate number of times 1 is present in this. Okay, so you will always be iterating that many times how many 1s are there in that number. Okay, so this number is having 7, so 7 has 4 set bits, so sorry, 3 set bits. Then this loop will iterate 3 times only. Let's say if you would have assigned 15, which makes this as 4 times 1, then this loop will go 4 times only. Okay, so this is the beauty of this. This runs very faster. There is another algorithm. There is something called table lookup, which gives you order of 1. I'm not explaining that because that is little tedious, and no one asks that table lookup technique in interviews. Okay, so I'll explain how this will work. Initially your count is 0. Now you will come inside by checking this number is non-zero. Yes, it is 7, it is non-zero. Then you will come inside and you will do AND operation of that number with the minus of itself. So how this will look like, it is looking like this: 0 1 1 1, and then AND of minus 1 will be 0 1 1 0. So this is looking like this. So if you will see here, by doing this AND operation, you will again get 6 only, like this one. Okay, so you are assigning 6 to that number. So now that number has become 6. Okay, and it will increment again, and then it will check number is non-zero. Yes, it is non-zero because it is 6. It will again come, and this time it will do something like this, like 0 1 1 0, and this time you have done minus 1, so it will cause 0 1 0 1. So this has become 5. So the answer of this one will be 1 into 0 0 0 into 1 0 1 into 1 1. So the answer will be 0 1 0 0. Okay, so this is nothing but 4 here. So now 4 will go here. You will check with the 4, and before that you will increment this count, and next time the 4 will come. So you will do this with 4 and the minus 1, which is causing it to become 3. So this is how 3 look like, and the answer to this one would be 0 0 0 0. Okay, now this time you will increment the count, which will make this count 3, and then you will come to check whether number is 0 or not. It is 0, then your for loop will terminate and you will print that. So we will see how it is printing. We have actually already saw that. So it is printing 3. So this is how we count the number of set bits in variable. I'm done here. Thanks for watching, and check out my other videos so that you will get so many interesting videos on C++. Thanks for watching. Bye bye. And the question is, what is the difference between shallow copy and deep copy? And when should you use shallow copy and when you should go for deep copy? Or the question could be, when you should rely on compiler generated copy constructor or copy assignment operator, or when you should create your own copy constructor and copy assignment operator. Okay, so we'll try to answer all those questions here. So this is the base class. It is having one pointer and another one is simple variable, integer variable, and this is default constructor, and this is where the deep copy is happening here. Okay, so I'm copying this RHS value into the left side object this is the left side object here. So I'm copying that. So this is the example of deep copy here. Okay, so we'll see how these things are working. So first of all, and yeah, these are the setters and getters of this pointer and value. So first what I will do, I will create a base object b1 and I will set some value 10 here to the pointer and 15 to the value. Okay, so this pointer will get 10 and this value will get 15 here. Okay, and now our b1 is ready with pointer assigned with 10 value and value assigned with 15. Okay, so now we'll assign this b1 to this b2. Okay, so here comes the deep copy concept. Okay, after assigning, I am changing the b2's pointer with value 50. So b1's pointer should have 10 value and b2's pointer should have 50 value. So we'll go and compile and we'll check with this print statement. So we'll compile and we'll check. So that b1 is having 10 and b2 is having 15. Okay, value is not changed, so value will be 15 and 15 at both location. So till now we are clear, but let's suppose I have not given this copy constructor, then also this program will work, will compile successfully and will run it, that is giving you this output. So if you notice here, you have changed this b2's pointer value with 50, but it changed b1's pointer also with the value 50. Before it was not there, but now compiler generated copy constructor is doing like this. Or you can say just because of the compiler generated copy constructor, this is happening. So this is something which you didn't want. You wanted b1 pointer to have 10 value and b2's pointer to have 50 value, but you changed b2 pointer which ultimately changed the b1's pointer. That you didn't want it. Okay, so how to overcome that problem? You need to implement your own constructor. Okay, so which is doing the deep copy. And what do I mean by deep copy? Deep copy is nothing but you create a new pointer. Okay, so this statement is creating a new pointer and you are setting the value of that pointer with the value of your RHS value. Okay, and this is very simple, so no need to explain this one. So this is where the deep copy is coming. You are creating a new pointer, and what compiler generated copy constructor is doing, that compiler generated copy constructor is doing something like this. Let's suppose b1 dot value is 10, so we are setting 10 here, so that value is 10, and b2 dot pointer is equal to 2000. That 2000 is nothing but the address this pointer variable is pointing. And if you will use this dereferencing operator, which is nothing but responsible for giving you the value at that address. Okay, so 2000 is holding 15 as value till this line. Okay, till this line, this is your code, or we can say this is the value. Now you didn't use this deep copy constructor, you rely on shallow copy. So compiler will do like this. This is the example of shallow copy. Compiler will simply copy the pointer of b1 into the pointer of b2. So b1 is having 2000 as its pointer value, and that 2000 was assigned to the b2's PTR. Now these b2 and b1 both are sharing the same memory location, and if you will change one value, then other will get the same value. Okay, so that's why it is happening. And why it is a problem? The problem is, let's say somewhere this b2 you deleted, like if let's suppose you created this b2 dynamically and you deleted that b2, or b2 goes out of scope or something, maybe you created b2 like this. Okay, let's suppose you created b2 in this scope. Okay, so this is another scope. Okay, b2 is created in this scope, so this scope will get enter, b2 will get created, b2 will get set here, and when you are coming out of this scope, b2 will get deallocated. And let's suppose you have created a destructor and there you are deallocating the memory what you created here. Okay, so what you will do, you will deallocate the memory. What is this? 2000. But this 2000 is pointed by b1 also, but that b1 will still be alive out of this scope. Okay, so there comes the dangling problem. Okay, you don't have the pointer, but still you are pointing to that address. Okay, and that is undefined behavior. So that's it, guys. Thanks for watching. Bye bye. And the question is, what is this GDB and how to use to debug your C and C++ code? Okay, and I will explain few commands like next, step, continue, breakpoint, break, trace, frame, and info. Okay, so there are lots of commands, but these are the basic command. Actually, I was asked this question when I was giving interview in my time. Actually, they gave me the laptop and they wanted me to debug their code. Okay, so maybe that is not possible in these days, but still it's always good to have some extra tool in your toolbox. Okay, so let's start now. So first I will explain you this next command. So first of all, you need to compile your code. So to compile, you need to give this -g switch here. Okay, so this is your CPP. So this is how you compile if you want to debug your code. Okay, so I will just simply compile that. Now how to debug that? It is very simple. Actually, there are lots of ways. I will show you one of the ways. You just simply write this GDB and your compiled code, or you can call it exe also if you are from Windows. Okay, so we'll just simply hit that. Now you are in GDB mode. There are lots of commands. So first of all, you need to keep a single breakpoint in order to break your program first. Okay, so first we will keep this break. You can break on line number, like first your program will start running from this main. Okay, so you can keep break at 21, 22, 23, or you can just break your program with the function name also. Okay, so first I will break with this main, like main, break main. So it will tell you that okay, I am breaking at this line 22. Okay, so it will stop here when we'll hit the run. Okay, so now you can hit the run here and your program will start running. Okay, so it has started running and it is stopping at 22. So this is what that line is. So there is another command called list, list, which short form is L only. So if you will press this L, you will see some of your program, like some part of your program. Okay, so as I told you that we are at this line right now. Okay, if you want to check, you can just simply check, like if you will press F, it will show you where are you right now. Okay, F stands for frame. So till now you have just started your program and reached to the first line. So there is another command called next. So this is the first command I want to show you here. So next is just enter next, then you will go to second line. Okay, so what you have done, you have initialized this main variable with 10. Now if you want to check how to check this main variable, you can just simply say that print main variable. Okay, and enter. It will tell you that okay, its value is 10. So what we have set here, 10. So this print will work. There are always short form for everything, like for print it is p only, main variable. So it will just print that only. Okay, so you no need to write this print. You can just simply type p and main variable, it will print that. And again we will press next. So yeah, there is another thing, n is short form for next. So if you will press next here, you will get this print here. Okay, like you wanted to print this main function, sorry, you wanted to print this main variable, and that main variable value is 10. So that is also printed here. And right now you are at 24th line, like function 1, like this one. Okay, so if you will press next here, then you will reach to return 0, because next is for next line. Okay, so if you will press next here at this location, then you will directly go to return 0. Okay, so that we can see here, just simply, yes, see, you have reached here, and this function 1 was called, function 1 is this one, and it was assigned 15, and 15 was printed, and then 20 was printed, and 25 was printed. So this everything is done, and at last you have reached here. But let's suppose you don't wanted that, you wanted to go inside this function 1 here. Okay, so how we will do that? So first I will quit this program again, or I can quit this, and I will just start this program again. I could have simply started from there only, but for simplicity I will start it again. So as I told, we'll keep the breakpoint here. So break main. Now we have one breakpoint. Now if you will run it, the short form for run is R. So you have run it here, and you have already reached to this point. So now let's say you press this next and next. Now don't press next here. You want to go inside this function 1, then press step. Okay, so this step is like you will go inside this function 1. Okay, so the short form for step is S. If you will press S, then you will go inside this. Okay, so it is telling like now we are at function 1. Okay, and that is at 17 line, this one, and this is the statement. If you will press next, we will execute this one. Okay, so this is how it is showing. So we will press next here. So this is assigned 15. We can just simply print function 1 and variable. So it will print 15 is the value for that variable what we have just simply assigned here. Okay, so this is how you print the variable inside the functions. And let's suppose you was doing lots of this checking like print, and you forgot, okay, at what line my cursor is. You can just simply press F and enter. It will tell you I'm currently at this line. Okay, so you can just simply press next, and this line was supposed to print the value, so it has print 15. Now it is at function 2. So the again you will do this step, you will go inside that function. Okay, we have reached to this function 2 here. Okay, and we have stopped here after entering into this function. So like this we go inside and inside and inside. So there is another command which is called backtracks. Okay, so if you will call backtracks, enter, it will show from where you are coming and at what point you are currently in your program. Okay, so you started from main, then from main you called another function called f1, so here, and from function 1 you called another function which is function 2. Okay, so you can see here function 2 you called here, and right now you are at function 2. Okay, so again to see where are you, you can just press F and enter. So you are at this location, you can just simply press next, and now don't press next here. If you want to go inside this function, then just type S. Okay, so now you have reached to this function 3 here. Okay, and this is the line it is stopped, so we will press next here. If you will press backtrace here, then you will see that right now we are at function 3. So you will see this one. See, you started from main, you came to function 1, function 1 called function 2, function 2 called function 3, and you are at function 3 here, and line number 9 it is showing that only. Okay, to be sure you can just print F, which is nothing but the frame, and it will show you, okay, you are at line number 1 and you are supposed to print this. Okay, if you will press next, it will print that. See, 25 is printed. It was supposed to print function 3 variable which is assigned 25 here. Okay, so till now we have seen this next step and continue. Okay, continue is something like okay, I will just simply start this program again. Let's suppose we have started this program, and if you want to see how many breakpoints you have kept, you can just simply do info B. It will show you how many breakpoints you have. So currently you are having only one breakpoint, which is this main. Okay, this info B is nothing but information about breakpoints. Okay, you can just simply delete also, like delete 1, then this will delete the breakpoint number 1. So this is number 1, you can just simply delete that also. So if you will do again that info B, you won't see anything, no breakpoints or watch points. Okay, so anyway, we need to keep some breakpoints so that our program will stop there and we will start debugging. So keep first breakpoint at main only, like break main. We'll just simply run that and we'll reach to that breakpoint. Okay, now I wanted to show you the use of continuous command here. So what we'll do, we know function 1 is calling function 2, function 2 is calling function 3, and function 3 is the last one. Okay, so it's working like this. You directly want to go to function 3, and function 3 is like you can just simply keep the breakpoint at function 3, like B function 3, enter. So it has kept breakpoint at 8 location. So this is the starting point of your function 3. So if you will press continue now, then you will directly reach to this function 3. Okay, no need to do this next and step and all that. You can just directly reach to this point. So first we'll see where are we currently standing. So press F, which is nothing but frame. So you are standing at 22 line. So this is 22 line. So you are currently at beginning. So if you will press C, this continue short form is C. So if you will press C, you will directly reach to this function 3. So it is telling you we are currently at function 3, and this is the next statement you will be executing. Okay, so you can just simply press next here and next. So like this it is working. So this next is done, step is done, continue is done, run is done, breakpoint is also done, backtrace is also done. Backtrace is nothing but currently you are at F3. How you reach to this F3? Okay, from main and function 1 and function 2, and currently you are at function 3. So this is what backtrace is. You can just trace back, see where are you and from where did you came to this location, and then frame. Okay, there is something important in frame. Let's say you are at function 3. Okay, so this is number, this is your frame numbers. Okay, frame is nothing but your functions. So whenever one function is called, one stack is created, so that is simply called frame. in GDBs. Okay, so this is one frame, another frame, and like this. So let's suppose currently you are at function 3, but you want to check some values of function 1 here at this point only. At this point, you don't want to run this program again and reach to this function 1. At this point only you want to check what is the variable. Let's suppose this function 1 variable value at this point. Then you can just simply go to that frame by typing frame number. Like this frame number is 2, function 1 is at frame number 2. You can just simply write F2. It will tell you you are at function 1. Okay, and now here you can just simply print function 1 variable. Okay, then you will get the output. If you would have printed that function 1 in frame number 0, which is nothing but your current position, let's go back to the frame 0, and if you will print this function 1, it will say no symbol, because this symbol is local to your function 1. Okay, so that's why you came back to function 1. Okay, this is your hierarchy. You came back in the hierarchy and you printed that. And there is one more command which is called info local. Okay, so that will print all the variables of local to that stack. So just simply local. So it will tell you that okay, function 3 variable is there and its value is 25, because currently we are at this location. Okay, so local to this function is only this variable. So I think I'm done here. Thanks for watching, and if you like the video, like and subscribe. Bye bye. And the question is, what is dangling pointer in C++? Okay, so this is one pointer. I have created dynamically memory for that. So okay, so first of all we will not initialize anything. Okay, this int is the size of the memory it is going to create. Okay, so this is done. After that, and then you are assigning this p1 to this p2, and after that you are sending this p2 to some function which is this one, this function. Okay, after that you are getting this pointer and I'm just printing it. Maybe you might be doing something world changing things here. Okay, after that you think that okay, now I don't want this pointer anymore, I will delete this, and by this mean you want to delete this p2 here. Okay, so you thought okay, it is not, p2 is no longer required here, so you will just delete that. After deleting this p2, you came back from this function and you started using this p1, because you didn't deleted this p1, you only deleted p2. But stop there guys, you copied p1 into p2. Okay, after that you are deleting p2 here, which is this ptr. In that case you are ultimately deleting this p1 also. Okay, so this is what the dangling problem is. Okay, you mistakenly delete some pointer and still you use that pointer. So after coming from this function here, you'll keep on using this p1 here, which is an undefined behavior. Okay, some people say that it is not undefined behavior, but it is an undefined behavior in some cases. Okay, or in almost all the cases. So we'll run this program and we'll check the output here. So we can just simply compile and run. So 0 0, and initially we can just simply assign this with 100 to some value. After compiling this, yes, you can see here, after copying here, we are printing this here first. Okay, so this function is getting called and you're printing this 100 here. After that you delete this pointer, you're coming back, and after that you're printing this p1, which was originally holding this 100, but that is printing you 0. That means that memory is freed, but still you're using that. So that is the problem. Actually you get 0 here, but maybe your memory can crash or something. Okay, so anything is possible. Here it is not crashing, but it can crash. Okay, so this is dangling problem. Thanks for watching, and check out my other videos, and if you like the video, please like and subscribe. Bye bye. What is segmentation fault and how to debug that? So the segmentation fault is nothing but the memory related problems, like you are going to access some memory which is you are not allowed to access. Okay, so these are the examples of that, like stack overflow. This is not the violation actually, but you're asking some extra memory which your CPU doesn't have. Okay, so in that case the segmentation fault comes. You're going to write somewhere which you are not allowed to write. Okay, so that time segmentation fault comes, and you are going to read from some location from where you are not allowed to read. Okay, so at that time also this segmentation fault comes. So this is a typical example here. We are going to assign this null into this integer pointer, and if you will assign this 10, that means you are going to dereference this null here. Okay, so that is a segmentation fault. So I'll show you the example how it looks like when it runs. Now we'll just simply compile this. So its name is app.cpp. Run this. It will tell segmentation fault. Okay, so your program always tell that you have segmentation fault, but it never tells where it is. Okay, so let's suppose you are having thousands and thousands line of your code. You might end up checking each and every line by debugging that where it is getting this segmentation fault, and sometimes it is input dependent. Like sometimes if it is random, then you really struggle so much to find that. So there is a solution for that. We can just simply use the GDB. I will explain how to use GDB in one of my previous videos. So if you don't know how to use GDB, you can go and check that video. Okay. So if you will do this ls, your code dumped file, this file has created. Okay. This file is nothing but the image of your process where it is dumped all those data, like when it got corrupted, what was the image of your process. Okay. So it creates this image so that you can just simply debug through this. If you will see this image, you won't be able to understand anything. Like, see, this is totally not readable code, but there is a way. This GDB will help you with that. Okay, so GDB a.out, your executable name, and this core name, and you will hit enter, and then simply run this. Oh, sorry, I just forgot to compile. You need to compile with G++ minus G option. Then only this will show you where this program is failing. Okay, so in order to get the proper line where this segmentation fault is coming, you need to compile this with this G option. I forgot that, so that's why it was not showing. Okay, so now if you will see again, it is telling you the code dump file is created. Now we will do this GDB a.out and core and the enter, and you just hit the run button here. It is telling you at this line we are failing. Okay, 15 number in app.cpp. Let's suppose you are having 10,000 files, then it will tell you that which file is responsible for your segmentation fault with the line number. Okay, so here you are dereferencing this null, that's why it is causing you the segmentation fault, and this GDB has directly tell you that where is the problem. So this is how we debug the segmentation fault. Okay, this is you can tell the problem is you are accessing some area which you are not allowed to access. Okay, this null you cannot access a null. Okay, but as I told you that there is a problem with stack overflow also. To get that error, we can just simply call ourselves. Okay, so in order to get that, we can simply call ourselves. So I'll just compile this code again. Okay, like GDB, and we will try to run this. It will tell you the same error. Segmentation fault has come because your main is calling itself again and again and again, and sometime it is going out of memory, so it is telling you segmentation fault. Okay, actually if you guys don't know how this recursion works, whenever you call some function, some stack is created, and to maintain that stack information you need to have some extra information like stack number or something. Okay, so that is also taking so much of memory. So in that case, when you create lots of stacks, you go out of memory. Okay, so this is what happening in here. So you're going out of memory. That's why this segmentation fault is coming, because somewhere someone is trying to increment some variable and trying to access some memory which is not there. Okay, so that's why this segmentation fault is coming. But you always try to remember all the time everything is related to the memory only. Okay, so we will try to debug this also. I will just do the GDB, our executable, and the code, and you just simply hit the run button. It will tell you you are getting segmentation fault at this line, at 14th line, so you can verify it here. Okay, so I think I'm done here. Thanks for watching. Bye bye. What is this pointer in C++? This is very common question in C++ freshers interviews. So let's look at what is the answer for that. Okay, so the first point you can tell is like this is passed as hidden argument to non-static member functions. Okay, so what is non-static member function? This is a non-static member function. Okay, we are not writing static here. If it is written static like this, then it is a static member function. Then in that case, this pointer will not be passed to this one. Okay, but if it is non-static member function like this, then this pointer will be passed, and this is also non-static member function. This is another type of member function. This is a constant member function where you cannot change the value. Okay, if you will attempt to change this a in this function, which is this function, you will get a compiler error. Okay, so let's see how this whole thing will work. So let's suppose there is a class, this class, and this is your data, and these are the interfaces you want to use this for changing this data. Okay, and let's suppose there is a base variable b and you are setting the value, let's suppose 10. Okay, so how compiler will treat it? Like this one. So the compiler will see this line, compiler will change this line into this line. Okay, that is how your this pointer gets transferred from here to the respective function. Okay, so this is the call to your function, which is this function. Okay, so in that case compiler has to do some modification. So when you write like this and compile your code, compiler change lots of things. Okay, so this is one of the thing. Compiler will change this into this. So like if you're calling this set value will be this set value, and your this pointer will be sent like this. Like b is having some address, your address will go here. So in order to get your this pointer, your compiler has to change this set value function also. So the compiler will change it like this one. Okay, so your set value will look something like this one. So this is how compiler will change this function. Okay, so first it will take this as a parameter. So your address of b is going as this here. Okay, and you was assigning this a, which is temporary, to this private a, which is nothing but your class data. Okay, so you was assigning like this, but compiler will change it like this one, this and your a. Okay, and then it will assign that a to this one. Okay, so the same thing will happen in this case also. Like suppose you are passing something, like I have not taken the example of this one here, so I will just simply write in here. Let's suppose you're taking get value. In that case compiler will change this also. Like suppose you are calling this one, then compiler will change this one like this one. Okay, in this it will send address of b. Okay, and we generally keep this getters. This is like you are getting the value, so you are not supposed to change any value. So we keep this constant for two reasons. Like compiler can optimize this code or whatever is written in that, because compiler know that you are not going to change anything inside that. So compiler can attempt to optimize things in this whole function. Or second thing is, you don't want accidental changes. Like you are just supposed to get the value, right? You're not supposed to change anything. Suppose this is one kind of restriction. Okay, so this a is getting returned. So in this case compiler will replace this with this one. Okay, so it is very similar, but just because of this constant in here, compiler will add one more constant, which is this one. In that case you cannot change the value also. Okay, before this constant was just because you cannot change this pointer. Okay, this pointer is nothing but the address. You cannot change address, which means you cannot make this b point some another address. B is having its own address and you cannot change that. Okay, so that is the reason this constant is here. So this is how this whole thing works. That's why you always get this pointer in your member functions. Okay, so I think I'm done here. Thanks for watching. And guys, please follow your passion. Do at least one time in a day what you're passionate about. Okay, that would make your life so much good. Thanks for watching. Bye bye.
What is function chaining in C++? So you might have heard about this, or you might not have heard about this, but still, yeah, let's go. We'll see how this will work. So function chaining is nothing but it looks like this. You will be having chain of functions. Like you are having one object, you are calling some function on that, then again you are calling some function on that, and then again you are calling on some function, and then you might be calling again and again and again. So this is like chaining the functions. Okay, and to achieve this you just only need to return this reference. Okay, we use function chaining just because we want some kind of intuition that in order to complete this one, like setting b, first you have to set a. Okay, then only you should go for setting b. Or in order to print this object, you must have set both the variables. So this is some kind of message to the user or the developer who is going to read your code or something. This is some kind of message to that guy. Okay, you could have achieved the same thing by just simply writing like this. Like you are writing b dot set a and setting some phi here, and then again b dot set b and setting 19 in that, and then b dot print. Okay, so this is also the same thing. Okay, but this is not showing that there has to be some sequence, because maybe developer can insert any number of code here or do something with this b which he is not allowed to do, or we can say he should not do. Okay, so to give that kind of message, we simply use this function chaining. Okay, that is a good way to give this kind of message, that please call this function first, after that you call this function, then only you should call this function. I'm taking very trivial example here, but you can think of any great example where first you need to set some variable, then only you should like perform some another operation. Okay, or let's suppose you are doing some animation, and first you want to animate something like b dot animate this one, let's say animate 1, and then after that you want to do animate 2. Okay, then again animate 3, so like this, and on and on and on. So in that situation, this function chaining comes very handy. Okay, so there could be lots of ways you can think of this function chaining could be useful. And again to say, if you want to achieve function chaining, you need to return the reference of your original pointer. Okay, so first of all, this b calling this set a function where you are passing this 5, so this 5 is being assigned to this a, and in completion of this function you are returning this, and this dereference means you are pointing at the object itself and you are returning the reference of that object. Okay, why reference? Just because maybe you want to change that particular object, and as you can see you are changing only the particular object. Let's suppose if you are not returning by reference, that then what could be the output of this? So first we'll go and check the output of this program. Okay, it would be 5 and 19 only, but still we can check that. So I will just simply compile this. What is the name? app2.cpp here, and we'll just simply run this. So as you can see, a is equal to 5 and b is equal to 19. Just in case you are not returning by reference here, now let's see what will happen here. Okay, we'll just simply compile and check, and the output is same. Here it is not giving the difference actually, but let me call this print function again. Okay, so here we'll get the difference now. Yeah, see, b was called here, b dot set a, so 5 was set and the object was returned. Here the copy of object was created. Okay, and now you are calling that set b on that copy of the object. Okay, not the b itself. So after that you are setting 19 on the copy, not the actual object. Okay, and after that you are printing. So in that situation you are printing the actual value. Okay, but when you are coming and printing b again, which should have 5 and 19 both, but in this case it won't have both, because when this set a was setting this 5, that time it didn't return the actual object. Here the copy of the object was created. Okay, so that's why 19 was set to the copy of the object, which is nothing but the temporary object. That's why it is showing 0 here. Okay, so this is how we deal with function chaining, and you should always return with reference only. Okay, so that you won't end up doing something which is really problematic. So see, if you are changing with this reference, you are having this correct output. Okay, all the time. So I think I'm done here. Thanks for watching. Bye bye.
So I will just compile this code so that we can just see it is working perfect. Yeah, so after inserting friend only, it started working. Why it is like that? There is two reasons. If you are calling this as friend, it means this doesn't belong to your class. Okay, this is outsider. Okay, so there are two ways of creating friend function. Either you declare a friend function here and define outside. Okay, so I have used it this way, but I will just simply create the other way also, so that it will be very easier for us to understand the topic here. Okay, so now let's compile this, and that's it. This is your friend function, and this is the definition of that. So generally we keep like this, but why do we need this friend? So there are two reasons. First is you want this function, this is a function, okay, operator, this is a function, you want this function not to be included as the base internal member function. First reason is that. And second reason is you are keeping this function as a friend just because you want to get the private part of your base. Okay, so that is the second reason. And why we don't want this part of your class is
just because when we call some functions like we know this base is being called here like this, then what is happening? Actually, you're calling this constructor like this one, okay? In this case, you're calling this constructor, okay? But how you're calling, when you're writing this program like this, your compiler will change this program into something like this. This base will have address of b1, 10. Okay, I have explained this whole thing in the previous video, that how you get this pointer inside your member function. We all know that we get something called this pointer in our member function, but how do we get that? So this is the way we get it. Okay, this line will get erased, and instead of this line, compiler will generate this line, and address of b1 is going at the first parameter internally. Okay, and this is also supposed to get changed here. So your compiler will change it like this. You will have something called base, and this base address this and integer x, and rest of the code will be similar like this one. Okay, but internally it will change, okay, here, but and this one is also this x. So this is how your compiler will change this line into this line. That is the only reason we always get this pointer inside our class. Okay, we all know we get this pointer, but we generally don't know from where it is coming. So compiler is changing our code, that's why we are getting this pointer like this. Okay, so all the classes and all the functions are always changed if it is not a static function, because you don't get static like this. Static is a straightforward calling, because that is not the part of your class exactly. Okay, you don't need this pointer in that static, okay, because you don't call static functions with your objects. So why I'm explaining all these things to you? The only reason is your class is getting changed because of this one, okay, and it is changing it itself. So don't you think if you would have not written this function here, then what your class will do? Your class will try to change this also, like it will create base pointer this comma and this one, and let's suppose I'm not having this one, or just keep it that way. Okay, so your class will try to do it like this, at least append this here. Okay, and when you're calling this, you will be calling something like this, operator less than. So as here you was calling the base with the help of b1, so that you was passing the address of b1, here you will pass cout. Okay, because this operator is attached to the left side of your operator, whatever is the left side. Okay, so left side is cout, which is part of your output stream. That's why you want this to be as output stream. Okay, that's why we write this o as stream at first parameter. Okay, that's why we overload our less than operator in this way. Okay, and second parameter is always your object, what you want to print. Okay, so that is the reason internally. So when you will write like this, your compiler will change it something like this, cout comma b2. Okay, so this is going to get called like this, and this will look for this function. Okay, so this is your function name here, and it is overloaded. And yeah, one more thing, this function is already present inside your IO stream, okay, or output stream. You are nothing but overloading it. Okay, so you are passing your own parameter, which is nothing but overloading your existing operator less than inside your IO stream. Okay, in order to show you that whatever I'm telling is correct, I will overload integer. Okay, so it will be very clear for you to understand in that case. Let's suppose I am overloading here for integer, and this is a fair overload. I can show you with this example. We all know we can do it like this. Okay, if you are going to print 10, it is going to print. Okay, but I have given this function explicitly, and this function is there inside your IO stream also, so it will tell you that you cannot overload this, and there has to be some ambiguity. So let's check that. I'll compile this code, and it is telling you compile time error, but there is this we have to find somewhere. Yeah, see, it is telling you ambiguous overload for integer. Okay, That means the same function is there inside this IO stream. Okay, that is the only reason we all happily print this integer value, because this kind of operator, overloaded operator, exists inside that. Okay, and what doesn't exist? This one doesn't exist. Okay, this is another overload of my own type, which is base. So this is whole thing. I think maybe I cleared the doubt why we keep friend here, and what is the reason of keeping it like this, like OS stream and all that. We always see that we need to pass first parameter OS stream. So what is the reason behind that? This is the answer for that. Okay, and please tell me if you have any doubt for this. Okay, I'll be very happy to explain all these things. Okay, so let's check out the next video.